So
So
let's start our
let's
session
start our
six
session
on
six
phase
on
transmission
phase
materials.
transmission materials.
Yeah.
Yeah.
So
So
in previous session,
in
I have
previous session,
discussed
I have discussed
a few things.
a few things.
Like we have
Like
went
we
through
have went
the
through the
nucleation,
nucleation part. Uh,
right? We have went
we
through
have
the
went through
nucleation
the
part
nucleation part
of both
of both
homogeneous and
homogeneous
heterogeneous,
and heterogeneous,
homogeneous and
homogeneous and
heterogeneous,
heterogeneous.
and also
And
I ended
also I
the
ended the
interfaces part,
interfaces part,
right?
right?
So we did the
So we
complete
did the complete
homogeneous nucleation
homogeneous
part,
nucleation
and
part,
there
and
was one part
there
left,
was one part
which
left,
was
which
the
was
substitution
the
part in
substitution
our
part in our
whole equation,
the
right?
whole
The
equation, right? The
heterogeneous
heterogeneous
nucleation cap model.
nucleation cap model.
So we'll do that
So
here,
we'll do that
and after
here,
that we
and
will
after that we
discuss
will discuss
about the
about
growth, the
the
different
growth,
types of
the
growth
different types of
process,
growth
and
process,
how
and how
uh,
uh,
the alloy
the alloy
solidifies, right,
solidifies,
or
right,
metal
or
solidifies.
metal solidifies.
So
So
let me
let me
complete the
complete the
heterogeneous
heterogeneous
nucleation part.
nucleation
So
part. So
so I have
So I
explained
have
what is the difference
explained what is
between
the
the
difference
homogeneous
between the
nucleation
homogeneous
and the
nucleation and
heterogeneous nucleation,
heterogeneous nucleation,
right?
right?
So the
So
probability
the
it's on
probability it's
depends
all
on the
depends
probability of
on the
finding
probability of
the
finding uh,
critical nuclear
critical
size
nuclear
is
size is
same throughout the
same
system,
throughout
but
the
in
system, but
heterogeneous
in
nucleation,
heterogeneous
which is not.
nucleation, which is not,
It
and
depends
why?
upon the
It
surface
depends upon the
energy.
surface energy term.
Okay, so
Okay, so
in total free
in
energy
total free
we
energy,
have
we
the
have the
volumetric free energy
volumetric free energy
and the surface free
and the
energy,
surface free energy,
the surface
the
energy,
surface
right?
energy,
So
right?
this term was
So this
negative
term was
and this
negative
term was
and this
positive,
term was positive,
right? So this term
right? So
will
this
dominate
term will
in
dominate in
heterogeneous, no
heterogeneous.
sorry,
No,
this
sorry.
term will
This term will
get reduced,
get
this term
reduced.
will
This
dominate.
term will dominate,
So
right?
that's why
So
we
that's why
had this
we had
heterogeneous
this
nucleation
heterogeneous
where we have
nucleation where we have
less barrier
less
compared to
barrier
the
when
homogeneous
compared to the
nucleation,
homogeneous
right?
nucleation,
So we were
right?
deriving
So
that
we were deriving
definition.
that
Let me
definition. Let me
uh,
um,
just rewrite that
just
formula
rewrite that
where
formula where
we didn't
we
complete it,
didn't
right?
complete
So
it, right? So
let's say
let's say
this is my
this is
surface
my
and
surface
this is
and
my
this is my
cap.
cap.
Let me
Let me
one more time.
one more time.
Yeah, let's
Yeah.
say this is
Let's
my
say
cap.
this is my cap.
Okay,
Okay.
now
Now
this is my strip.
this is my strip.
Okay, before
Okay.
that and
Before that,
how
and how
we did arrive
we
to
did
this
arrive to this
part where
part where
delta g,
delta
which depends
G,
upon
which
the
depends
function of
upon
r,
function of
will be
R,
equals
will
to
be equals
minus
to minus
volume of the cap
volume of the cap
times
times
delta
delta
GV, the
GV,
volumetric
the
change free
volumetric
energy,
change free
plus
energy,
the
plus
area of the
the
cap
area of the cap
times,
times,
let's say,
let's say,
uh,
uh,
this is my area of the
this is my
cap.
area of the cap.
Now, let
Now,
me
let me
write those
write those
free energies part.
free energies part. Okay.
So, let's say
So
this is
let's
my
say this is my
cap,
cap.
then this is
Then
after
this is
nucleation.
after nucleation.
Let's say this is my
Let's say this
mold,
is my mold.
this is my
This is
liquid,
my liquid,
and this is my
and this is my
solid.
solid.
Okay, now
Okay. Now,
before nucleation,
before nucleation,
I have solid.
I have solid.
Oh, no,
Oh,
it's
no,
not
no,
solid.
it's not
It's
solid.
the liquid.
It's the liquid.
It's
It's
the liquid
the
and
liquid
the mold.
and the mold.
These are my two
These are
parts.
my two
Okay,
parts.
before
Okay,
nucleation.
before
Now
nucleation.
this is my
Now
after
this is my
nucleation.
after
Now
nucleation.
what
Now
what is happening
what
here?
is happening here?
So I
So
have a
I
solid
have a
that is
solid
formed
that is
on a
formed on
liquid,
a
right?
liquid, right?
So before
So before
nucleation,
nucleation, the surface energy,
which is
which
only
is
the
only
gamma
the
liquid
gamma
mode,
liquid
right?
mode, right?
There is only
There
the,
is only the
suppose these are my
suppose
liquid
these are my
atoms
liquid atoms
and these are my
and
mold
these are my
atoms,
mold atoms,
right?
right?
Then my
Then my the surface energy or the surface tension is just this one, right? Just like I have shown here. It's just the blue one. Okay, so that is the surface energy of liquid and the mold.
now
Now,
because of
because
this
of
formation,
this
the
formation,
solid
the
formation,
solid
first
formation,
there is a
first there is a
destruction of this
destruction
one,
of this one,
or the
or
disappearance
the
of this energy,
disappearance of
right?
this
The
energy,
destruction
right?
of
The destruction of
gamma L, the
gamma
surface
L,
energy
the
of
surface
liquid and
energy
mold,
of liquid and mold,
which is removed.
which is
Now,
removed. Now,
after that,
after that,
we have formed,
we have
let's say,
formed, let's say,
this is the
if
point I
this
am
is the
seeing,
point I am
and
seeing,
this
then this
is my
is my
what?
what?
We have liquid
We
and
have
we have
liquid
solid.
and we
So
have solid. So
gamma
gamma
or the surface
or the
energy or
surface
the
energy
interface
or the
energy of
interface
liquid and
energy of
solid.
liquid and solid.
Here,
Now here,
it is again the
it is
same one,
again the same one,
the gamma,
the
liquid
gamma, liquid
and mold.
and
And
mold.
what about here?
And what about here?
This is
This
the
is
gamma,
the gamma,
solid and
solid
mold.
and mold.
Right. Now these
Right.
three are
Now these
balanced
three are
for
balanced for
these three
now
surface
these three
tensions or
surface
surface
tensions
energy
or
must be
surface energy
balanced,
must be
so
balanced
that
so that
to
to
maintain this shape
maintain this shape
or to wet
or to wet
the mold.
the mold.
Right.
Right.
Now
Now
this is my
this is my
surface tension.
surface
Now
tension.
if I
Now
try
if
to
I
balance
try
those
to balance
forces,
those forces,
which will turn out to
which
be
will turn out to be
gamma Lm
gamma
will be
Lm
equals to,
will be equals
or
to,
the
or the
interface energy of
interface
liquid and
energy of
mold
liquid and
will
mold
be equals to
will be equals
interface
to
energy of
interface
liquid
energy
solid
of liquid solid
of cosine term
of cosine term
plus
plus
interface energy of
interface energy of
solid and
solid
mold.
and mold.
Now
Now,
this is very
this
important
is very
relation
important
which will be
relation which will
used
be
in
used in
next part.
next
Okay.
part. Okay.
Now
Now,
see we have shown
see,
here.
we
Now
have
this is
shown here.
this
Now, this is
area
this
strip.
area
Now we
strip.
know
Now we know
where this is coming
where
from,
this
right?
is coming from, right?
So here I have
So here
mentioned
I have mentioned
there is a
there is
formation
a
of these two
formation of
terms,
these
right?
two
These
terms, right?
two
These
energies are
two
appearing
energies
after
are appearing
nucleation.
after
What are
nucleation.
the two
What are
interface
the two
energies
interface
that are
energies
appearing?
that are
One
appearing?
is the
One is the interface energy
solid
of
liquid
solid
and
liquid
solid mode.
and solid
So
mode. So
we are going to write
we are
those
going to
terms.
write those
Area of
terms.
the
The
cap
area of the cap
times
times
the interface
the
energy of
interface
solid
energy of
and
solid
liquid, because
and
that
liquid,
is
because that
touching,
is
right?
the
So
touching,
this
right?
solid
So this
is
solid
touching the
is
liquid.
touching the liquid.
So that's why we
So
take the
that's why
total
we
surface
take the
area of
total
the cap
surface area of that cap
times
times
the area, not
the area,
total
not
surface area,
total
but
surface
only the
area, but
surface area of
only
the
the
top
surface
part,
area of the
right?
top part, right? The
Section,
circular
this circular
section, this
section.
circular section.
Okay. So
Okay.
that's why we are
So
taking
that's
this,
why we are taking this,
integrating this area strip
integrating this area strip
plus
plus
area of
area of
this circle,
this circle,
right? The area
right? The
bottom.
area
So there
bottom,
is the
right? So
top
this
one,
is the top one,
this is the bottom.
this is the bottom.
Okay, the bottom
Okay,
of the
the
cap, which
bottom
is
of the
just a
cap, which
circle,
is just a circle,
right? So it
right?
will,
So it will,
from this, if you
from
see
this,
from here,
if you
it will
see
look
from
like a
here, it will
circle,
look like a circle
times gamma
times gamma
solid and
solid
mode.
and
Now what
mode.
is the
Now, what is the
interface
the
energy that's
interface energy that has been destroyed,
which is
which is
same
same
as the bottom
as the bottom
area of the cap
area of that cap
times
times
gamma
gamma
Lm,
Lm,
right? The interface
right?
energy
The
of liquid
interface energy
and
of
mode.
liquid and
So
mode.
this is
So this
the term how
is
we
the term
derived
how we
or
derived
how
or
we used
how we
there.
used there.
Now
Now,
coming to this part,
coming to this part,
say
let's say
I'll write more
I'll
clearly.
write more clearly.
Now
Now,
this is my strip.
this is
Now
my strip.
if you are
Now,
doing
if you are doing
integrating, you just
integrating,
take a
you just take
unit
a
strip.
unit strip. Okay.
So
So
if I
if I
zoom it,
zoom
it will
it,
look like
it
this.
will look like this.
Right.
Right.
Now
Now,
let's find what is the
let's
surface
find
area.
what is the surface area.
So
So
if I want to know
if
the
I
surface
want to know
area,
the surface
which
area,
will be
which
equal
will
to
be equal to
AL
AL,
will be equals to
will be equals to
1
1
2
2
pi
5
r
R
times
times
dr.
dr.
This is my
This is my
dr.
dr.
Right. Now
Right. Now,
let's say
let's say
this
this
looks
looks
like
like
this, and this is
this,
my
and this is my
radius.
radius.
Okay.
Okay.
Now
Now,
if this is
if
my
this
radius,
is my radius,
which
which
makes
makes an angle
theta
theta
with this guy,
with this guy,
and
and
the the one
the
extremity,
one
right? This is the
extremity,
point
right? This
one,
is the
and
point
this is the
one,
point
and
two.
this is point
The
two.
point one
The point
and
one
point
and point
two
two
will make
will
an
make
angle
an
with
angle
the center
with the
of
center of
d theta.
d theta.
Okay,
Okay.
so one is
So
theta.
one is theta.
The point one
The
will
point
make
one
an
will
angle
make
theta,
an
and the
angle
point
theta,
two will
and the
make
point two
angle
will make
theta plus
angle
d theta.
theta plus d
So the
theta.
difference
So
between
the
one and
difference
two is
between one and two
the
is
angular
the angular
relation between one and
relation
two,
between one
and
and
the
two, or the
displacement between
angular
one and two
displacement
is
between
d
one and two
theta.
will be d theta.
Now
Now,
we know the locus of a, we know the
surface,
definition
we
of
know
a
the
sphere,
definition of a
right? Or
sphere,
definition of a
right? Or
circle.
definition of a circle.
The
The,
point of
the
locus
point
which is
of locus which is
equidistant from one
equidistant
point,
from one point,
which is the radius.
which is the
So
radius, right? So
from wherever
from
take
wherever
from
take
wherever we
from
measure the
wherever we
distance
measure
from
the
center to
distance
the
from
surface
center
of
to
the
the
sphere,
surface of
it
the
will be
sphere,
r.
it will be r.
So this will be r
So
and
this
this
will
will be
be
r.
r and this will be r, right?
Now what will this
Now
one?
what will this
So
one? So
yeah, then what is
yeah,
r?
then what is
So
r?
small r.
Smaller.
Small r will be
Small r will be
r
r
sine theta,
sine theta,
right?
right?
Because let's say this
Because
is
let's
a
say this is a
rectangle triangle,
rectangle
and
triangle,
I'm seeing
and
from
I'm
here,
seeing from here,
then sine theta will
then
be
sine
r
theta will
by
be r
capital R.
by
So r
capital R.
equals to
So
r
r
sine
equals to
theta.
r sine theta. Now
2 pi r
2 pi r
sine theta.
sine theta.
Again, what is my
Again,
dr?
what is my dr?
We
Now
know
we know
if we have an
if we
arc,
have an arc,
the arc length,
the arc length,
and we have a
and we
theta,
have a
and
theta,
we have a
and
radius.
we have a radius.
Now we have a very
Now we
famous
have a very
relation
famous relation
from
from
Taylor's
Taylor's
approximation.
approximation.
Theta will be
Theta will be
arc length
arc length
upon
upon
radius.
radius.
So
So
our
our
dr will be
dr will be
r
r
d
d
theta.
theta.
That's right.
That's
Because
right.
this is the
Because
distance.
this is the
Let's say this
distance.
is the
Let's say this is
two
the
extremity
two
points,
extremity points.
and if I join the
And if I
center,
join the
then the
center,
angular
and the
displacement will
angular
be d
displacement
theta,
will be d theta,
and the
and
distance, the
the
arc length
distance, the
is
arc length
dr,
is dr,
and the radius is
and the
r.
radius is r.
So that's how
So that's
we
how
arrive here.
we arrive here.
So 2
So
pi
2
r
pi r
square
squared
sine theta
sine theta
d theta.
d theta.
This is dA. Now
This is
what I'm
dA.
going to
Now what
do
I'm going to do
is integrate
is integrate
0 to a
0 to a, 0 to theta.
that will be
That will
area
be area of that cap
will
will
be
be
equals
equals
to
to
top
top,
portion
from top portion
of the surface,
of the
total
surface,
surface area.
total
So only
surface
the
area.
top
Only
surface
the
area,
top
right?
surface
Not the
area,
bottom
right?
one.
Not the bottom
Bottom
one.
one is just pi
Bottom one
square.
is just pi r square.
Yeah. So
Yeah.
that will be
So
equals
that
to
will be
2
equals to 2
pi
pi
r square
r square
integral
integral
of
of sine theta
will be
will be
minus cos theta,
minus cos theta,
right? So
right?
you have
So
minus
we have minus
cos theta.
cos
Now
theta.
you multiply
Now you
minus with
multiply
respect
minus
to
with
this upper
respect
and
to
lower
this
limit.
upper
This
and lower
will
limit. This will
interchange.
interchange.
That will be
And
equals
that
to
will be equals to
2 pi
2
r
pi
square.
r square.
Cos 0 will be
Cos
1.
0 will be
1
1,
minus
1
cos theta.
minus cos theta.
This is the top
This
surface
is the
area.
top
Now
surface
what will
area.
be the
Now
bottom
what will be in
surface
the
area?
bottom surface area?
Will be equals to,
Will be equals to,
it's just a pi r
it's
square.
just a pi r square.
So pi
So
r
pi
square.
r square.
It's not
It's not
capital R. It is
capital
smaller.
R, it is
So
smaller.
r will be
So r will be
r square
r square
sine square
sine square
theta.
theta.
Now what is the
Now
volume?
what is the volume?
Volume of the
Volume of
cap
the cap
will
will
be
be
equals
equals
to,
to,
again,
again,
if I try to
if I
zoom
try
it
to zoom it.
now,
Now
we
we
only
only
know
know
the
the
formula
formula
of
of
cylinder,
cylinder,
right? Which is
right?
pi r
Which
square
is
h.
pi r square h.
Now we are going to
Now
apply
we are
that
going
here,
to apply that here,
right? So
right? So
dvc
dvc will be equals
pi
to pi
small r square,
small r
small
square,
r square.
again small
What
r
is
square.
h?
What is
My
h?
h is
My
this
h
distance,
is this
not this
distance,
one,
not this one,
right?
right?
So
So
again,
again, I have
made
made
a
a
mistake
mistake
in
in
last
last
session.
session,
So please
so please
refer to this one.
refer to
So
this one.
this is my
So
d
this is
theta,
my d theta,
right?
right?
And this is
And
making
this
my
is
angle
making my
theta.
angle theta.
Okay.
Okay.
Yeah. So this is my
Yeah. So
angle
this is my making an angle theta.
then
Then
with respect to the
with
normal.
respect to the normal.
Okay.
Okay.
And if I want to
And
know
if I
this
want to
guy,
know this guy,
so from here
so
we can
from
say
here you can
this is
say this
theta,
is theta,
right?
right?
And what about this?
And
This is
what about
90
this? This
minus
is
theta.
90
Then
minus
again,
theta. Then
this will be
again,
my
this will be my
theta.
theta.
Simple.
Simple.
Now
Now
Yeah, I want to know
Yeah,
this
I
one,
want to
so
know
I
this
know
one.
this
So
is
I
my
know this
dr,
is my dr,
right?
right?
And I want to
And
know
I
this
want to know
dh.
this dh.
Okay, now what is
Okay.
dh?
Now what is dh?
Dh will be
Dh will be dh
dh will be equals to
will be equals to
sine. Now
sine.
if I
Now
see
if
from
I
this
see
one,
from
so
this one,
sine theta
so
will be
sine theta
equals
will
to
be equals to
dh opposite
dh
side by
opposite side by
hypotenuse. So dh
hypotenuse.
will
So
be
dh will be
sine theta
sine theta
dr.
dr.
Now if I substitute
Now if I
here,
substitute here
the
the
dh in this
dh
one,
in
so
this one,
sine
so
theta
sine theta
dr.
dr.
Now we know what is
Now
r.
we know what is
Again,
r again,
pi
pi
r square
r square
sine
sine
cube
cube
theta.
theta.
Now what is dr?
Now what is dr?
Again from here,
Again from
our
here
dr is
our
r
dr
d
is
theta.
r d theta
R
r
d theta.
d
So r
theta.
will
So
come
r
out.
will come
That will
out.
be
That
pi
will be pi
r cube
r cube
sine cube
sine cube
theta
theta
d theta.
d theta.
Now this is my
Now this is my
volume.
volume.
Now if I
Now
do
if I do
the integration
the
part,
integration part,
right? So
right? So
that will be
that will be
VC
VC
by r cube
by r cube
sine cube
sine
theta
cube theta
d theta.
d theta.
Now
Now
what is
what
integral of
is integral of
sine power
sine power
n theta,
n theta,
which is minus
which is
sine.
minus
I have derived
sine.
this
I have
relation,
derived
so
this
please
relation.
refer
So
to the
please
previous
refer to
session.
the previous session.
N minus 1
N minus 1
theta
theta
cos theta,
cos theta,
right,
right?
minus
Minus
n minus
n
1
minus 1
divided by n,
divided by n,
right?
right?
So
So
should I
should I
derive this part again?
derive this part again?
No, again it will
No,
take
again it will
too
take
much time. So
too
let
much
me
time. So let me
write this
write this
relation
relation
just as it is,
just as it is,
so that I
so that
don't waste time.
I
So
don't waste time. So
sine power n
sine power
minus 1
n
theta
minus 1 theta
cos theta.
cos theta.
So that
So
will
that
be,
will be,
yeah, n
yeah,
minus 1
n minus
sine,
1 sine, uh,
yeah,
yeah,
maybe
maybe
there's a mistake
there's a
somewhere.
mistake somewhere.
Let me check it.
Let me check it.
It should be
It should be,
again, let's say
let's say,
integral of sine
integral of
power
sine
n
power
minus
n
1
minus
theta
1 theta
and
and
sine theta
sine theta
d theta.
d theta.
Okay,
Okay.
now let's
Now
take,
let's take,
we know
we
integral of
know integral
u
of u
dv will be equals
dv
to
will be equals to
uv minus
uv minus integral of v
okay,
du.
so let's take
Right.
this
So
as
let's
u,
take this as
this
u.
is as
This is as
dv.
dv.
Then
Then
du will be equals
du will
to
be equals to
n minus
n
1
minus 1
sine power n
sine power
minus
n
2
minus 2
x of
x
theta.
or theta.
Then
Then
differentiation of sine theta will
differentiation
be
of sine
cos
theta
theta
will be cos
d
theta
theta.
d theta.
What about u?
What about
U will be
u? U
minus
will be
cos
minus
theta,
cos theta.
right? So
Right. So
let me substitute
let me
this term
substitute
there.
this term there.
Yeah. What
Yeah.
is my u?
What is my u?
U is
U
minus
is
sine
minus
power
sine
n
power
minus
n
1
minus 1
theta,
theta,
and we have
and
cos
we have
theta
cos theta
minus,
minus.
what else I have?
What else I have?
I have n
Have
minus
n
1.
minus 1.
This
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 cost
constant
term
will
and
be
this constant
multiplied
will be
and this will
multiplied
become
and this
plus.
will become
So
plus. So
cos square
cos
theta
square theta
sine power n
sine
minus
power
1
n minus
theta
1
d
theta
theta,
d theta.
right?
Right.
Let's not write this
Let's
term.
not write
So
this term. So
now you know
now you
identity,
know
cos square
identity
theta is
cos
equal to
square
1
theta is
minus
equal to
sine
1
square
minus
theta,
sine square theta.
right?
Right.
So
So
integral of
integral
n
of
minus
n
1
minus 1
1 minus
1
sine
minus
square
sine
theta
square theta
sine power
sine
n
power
minus
n
1
minus 1
theta
theta
d theta.
d theta.
So upon
So
multiplying,
upon multiplying,
it is n minus
it
2.
is n minus
Upon
2.
multiplying
Upon
this 1 and
multiplying
2,
this 1 and 2,
so
so
if I do the
if I do the
simplification,
simplification,
then
and
this is n minus
this is
2.
n minus 2. So
Sine power
sine
n
power
minus
n
2
minus 2
theta
theta
d theta
d theta
minus
minus
n minus
n
1
minus 1
integral of
integral of
sine power
sine power
n
n
d
theta
theta.
d theta.
Now we already
Now
have
we
here
already have
sine
here
power
sine
n
power
theta d
n
theta.
theta d theta.
So
So
if I exchange
if I
terms
exchange
from here
terms
to
from
here,
here to here,
so
so
my
my
yeah, so
yeah,
minus 1
so
plus 1 will
minus
get
1 plus 1
cancelled.
will get
We will be
cancelled. We
remained with
will be remained with
n
n
integral of
integral
sine
of
power
sine
n
power
theta
n theta
d theta,
d theta,
which will be equals to
which will be equals
minus
to
sine
minus
power n
sine
minus
power
1
n
theta
minus 1 theta
cos theta.
cos
And
theta.
if I
And if I
just
just
divide it on both
divide
sides,
it
so
on both
it
sides,
will
so
be
it will
1 by n.
become 1 by n.
And
And
what are the other terms
what are
that
the
are
other
remained?
terms that are remained here?
Yeah, so
Yeah. So
yeah, we remained with
yeah,
this
we
one.
remain
So
with this one. So
n minus
n
1
minus 1
sine power
sine power
sine
sine
n minus
n
2
minus 2
theta,
theta,
right, d
right,
theta,
d theta,
n minus 1 by
n minus 1 by
n.
n.
So this is our
So this is
relation.
our relation.
Now what
Now
we are trying to
what
do,
we
we
are
are
trying
trying
to
to
do, we
do
are trying to
find
do
sine cube
find
x,
sine cube x,
right?
right?
So
So
this will be,
this will be, let me write
so
this.
minus
So minus
sine,
sine,
what is cube
what
x?
is cube x?
3 minus
3
1
minus 1
x
x
or theta
or theta
cos theta
cos theta
divided by
divided by
3
3
plus
plus
integral of,
integral of,
here we have
here we
3
have
minus
3
1
minus
divided
1
by 3
divided by 3
and
and
sine power n
sine
minus
power
2,
n minus
so
2.
it will be
So it will be
sine 3
sine
minus
3
2
minus 2
d
theta
theta.
d theta.
So how much is
So
this
how
one?
much is this
This
one?
is
This is
sine square
sine
theta
square theta
cos
cos
theta
theta
divided by
divided
3
by 3
plus
plus
2 by
2
3
by 3.
integral of sine theta
Integral
will
of
be
sine theta will be
minus cos theta.
minus cos theta.
So it is
So it is
minus cos
minus
theta
cos theta
again.
again.
Now
Now
minus,
minus,
if I take
if I take
cos 3 by
cos
t,
3 by t,
if I take minus
if I take
common,
minus
and
common,
also
and also
cos
cos
theta by
theta by
3,
3.
this will be equals
This
to
will be equals to
sine
sine
square theta
square theta
plus 2,
plus 2,
right, which will
right?
be equals
Which
to
will be equals to
1 plus,
1 plus,
this can be written as
this
1
can be
plus
written
1,
as 1
and we
plus
know
1.
1 plus
And we
sine
know
square
1 plus
theta
sine
equals
square
to
theta equals to
2 cos square
2
theta.
cos square theta.
No, no, no.
No, no, no.
So
So, yeah. Yeah.
so we have n
So we
minus
have
1
n minus 1
integral of sine n
integral of
minus
sine
2
n
theta
minus
d
2
theta.
theta d theta.
This is multiplied
This is
here,
multiplied here.
and
And
we had
we had
this term, so
this
this
term.
term
So
will
this
go
term
on that
will go
side.
on that side.
We had cancel
We
out,
had cancel
so we
out.
are
So
remained
we
with
are remained
minus
with
sine power
minus
n minus
sine
1
for n
theta
minus
cos
1
theta
theta
divided
cos
by n
theta
plus
divided by
n
n
minus
plus
1
n minus 1 by n
minus 2.
minus 3 divided by theta.
So
So
we will be remained
we will
with
be remained with
minus
minus
cos theta
cos theta
plus
plus
cos cube
cos
theta
cube theta
divided by 3,
divided by 3.
right?
Right.
Now
Now,
if I substitute
if I substitute
from 0 to
from
3,
0 to 3,
this will turn out to
this
be
will turn out to be
2 minus
2 minus
3 cos
3
theta
cos theta
plus
plus cos cube theta
divided
divided by
by 3.
3.
Right, now this is
Right,
my
now this is my
volume, volume
volume,
of the cap
volume of the cap
into
into
pi
pi
r cube.
r
So
cube.
what I'm trying
Now
to
what
do
I'm
is
trying to do is
I'll just multiply
I'll just
4 and
multiply
4
4 and
both
4
sides. So
both
it will
sides.
be
So it
4
will be 4
pi
pi
pi r
by
cube by
pi r
3
cube by 3
times 2
times
minus
2
3 cos
minus 3
theta
cos theta
plus
plus
cube
cos
theta
cube theta
divided by 4.
divided by 4.
This term can be written
This
as
term
f
can be
of
written
theta,
as f of
which is the
theta, which is the
total function of
total
theta.
function of theta.
Right?
Right?
Now
Now
let me
let me
fill this all
fill
things
this all
into that
things into
equation.
that equation.
Here is the equation.
Here is the equation, right?
Yeah,
Yeah,
where
where
is
is
that
that
equation?
equation?
Yeah, in this
Yeah,
equation.
in this equation.
Now
Now
delta g r
delta
will be
G
equals
R
to
will be equals to
minus 4 by
minus 4
3
by
pi
3
r
pi
cube
r cube
times
times
the f of
the
theta
f
term
of theta term
plus
plus
what was my
what
area
was
term?
my area term?
Area term is
Area term
2 pi
is
r
2
square
pi
1
r
minus
square
cos
1
theta
minus cos theta
for
for
2 pi
2
r
pi
square
r
into
square
1
into
minus
1
cos
minus
theta.
cos theta.
This is for which
This
term?
is
This
for
is
which
for
term? This is
the
for
interface
the
energy of
interface
solid
energy
and
of
liquid
solid and liquid
plus
plus
pi r
pi
square
r
sine
square
square
sine
theta.
square theta.
This is
This is
solid and
solid and
mold
mold
minus pi
minus pi
r square
r
sine
square
square
sine
theta.
square theta.
This is
This
interface
is
energy between
interface energy between
liquid and mold.
liquid and mold.
Now,
Now,
if I do the
if I do the
some mathematical
some mathematical
jugglery, let's
jugglery,
write this
let's write
volumetric
this
term as it
volumetric
is.
term as it is.
Then I'm remind
Then
with
I'm remained with
2 pi
2
r
pi
square
r
gamma
square
SL
gamma SL
minus 2 pi
minus
r
2 pi
square
r
cos
square
theta
cos theta
gamma SL
gamma SL
plus
plus
pi
pi
r square
r
if I
square
take pi
sine.
r
If I
square
take
sin
pi r
square theta
square sine
common,
square theta
then
common,
I am remind
then
with
I am remained with
gamma
gamma
interface energy
interface energy
of
of
solid mold minus
solid mold
interface
minus
energy of
interface energy of
liquid and mold.
liquid and mold.
And we have this
And we have
relation
this
where
relation where
gamma solid and
gamma
molds
solid and
interface energy
molds
of solid
interface
and
energy
mold
of
will be
solid and
equals
mold
to
will be equals to
interface energy of
interface energy of
solid liquid
solid liquid
times cos
times
theta
cos
plus
theta plus
solid,
solid,
or you can say
or you
solid
can
and
say
liquid.
solid and liquid.
No, it's not solid and
It's
liquid.
not solid and liquid.
It is
It is
interface energy of
interface energy of
liquid and
liquid
mold,
and mold,
which will be equals
which
to
will be equals to
solid and mold.
solid and mold.
Right.
Right.
Now I have the
Now
term
I have the term
gamma SL minus
gamma
gamma
SM minus
ML,
gamma
which will be
ML,
equals
which
to
will be equals to
this term will be equals
this
to
term will be
minus
equals to
gamma
minus
SL cos
gamma
theta.
SL cos theta.
If I
If
substitute
I
there,
substitute there,
again I'm not going
again
to
I'm
write
not going to write
the volumetric
the
term.
volumetric term.
Yeah,
Yeah,
let's write it as it
let's
is
write it
2
as
pi
it is 2
r
pi
square
r
gamma
square
surface
gamma
energy
surface energy
minus 2 pi
minus 2
r
pi
square
r
cos
square
theta
cos theta
myself
myself
plus
plus
this is only pi
this
r
is
square.
only
There is
pi
no
r
2 pi
square. There
r
is no
square.
2 pi r
Now pi
square.
r
Now
square
pi r square
sine square
sine
theta
square theta
minus gamma
minus
SL
gamma
cos
SL
theta.
cos theta.
Now upon
Now
multiplying
upon multiplying
2 pi r
2
square
pi
gamma
r
SL,
square gamma
so
SL, so
yeah,
yeah,
2 pi
2
r
pi
square
r
gamma
square
SL
gamma SL
minus 2 pi
minus
r
2 pi
square
r square
cos theta
cos theta
gamma SL
gamma SL
plus, or it will
plus,
become
or it
minus,
will become minus,
right?
right?
So it will become
So it
minus
will become minus
pi r square
pi r square um,
let's write all the
let's
terms
write
in
all the terms in
cosine terms. Okay.
cosine terms. Okay.
Then sine square
Then
theta
one
will be
sin square theta
1
will be
minus cos
1
square
minus
theta,
cos square
which
theta,
will be
which will
cos
be
theta
cos
minus
theta
cos cube
minus
theta.
cos cube theta. Uh,
2 pi
2
r
pi
square
r square
gamma
gamma
SL
SL
minus,
minus,
see you have
see you have
2
2
pi r square
pi
gamma
r square
cos
gamma
theta
cos
gamma SL
theta gamma
and
SL
pi r
and
square cos
pi
theta
r
gamma
square cos
SL,
theta gamma SL.
right?
Right.
So
So
this will become
this
3,
will become 3.
3 times 3
3
pi
times 3 pi r square
cos theta
cos theta
gamma SL.
gamma SL.
Minus
Minus
into
into minus
minus plus,
plus,
and
and
it
it
will
will
become
become
pi
pi
r
r
square
square
gamma
gamma
SL
SL
cos cube
cos cube
theta.
theta.
Now I'm
Now
going to write the
I'm going to
volumetric
write
term
the
as it is.
volumetric term as
If
it
I
is.
take
If I take
pi r
pi
square
r square
gamma SL as
gamma
common,
SL as
then it will be
common,
2
then it will be
minus
2
3 cos
minus 3
theta
cos theta
plus cos cube
plus
theta.
cos cube theta.
Now, I'm
Now,
going to write the
now I'm going to
volumetric
write the
term
volumetric term
minus 4 by 3
minus
pi
4
r
by 3
cube
pi r cube
gamma.
gamma.
It's not there. Is no
It's not
gamma
there is
SL.
no gamma SL here. We have
F of theta
f
term.
of theta term,
F of theta
f
function,
of
right?
theta function, right?
Of
Of
theta
theta
plus.
plus.
Now what I'm going to
Now
do is
what I'm
again
going
I'm
to do
going to
is
do
again
the
I'm
same.
going to do the same.
Divided by 4,
Divided by 4,
multiply by 4.
multiply by 4.
This will become
This
4
will
pi
become 4 pi
r square.
r
Again we
square.
have
Again
f
we
of
have
theta term.
f of theta term.
So if I take
So
f of
if I
theta
take
term
f
as
of
a
theta
common,
term as a common,
minus 4 by
minus
3 pi
4 by
r
3
cube
pi r cube
plus 4 pi
plus
r
4
square
pi r square
gamma SL
gamma SL
times
times
f of
f of
theta term. This is my
theta term. This is my
delta G
delta G
heterogeneous.
heterogeneous.
Right. Now how does
Right. Now how
this one look
does
like?
this one look
This
like?
one looks like
This one looks like
delta G
delta G
homogeneous.
homogeneous.
Right. So we
Right.
can
So
write
we
this
can
relation in
write
a
this
simple
relation in a
form.
simple
Delta
form.
G
Delta
hetero
G
will be
hetero
equals
will
to
be equals to
delta G
delta G
homogeneous times
homogeneous
f of theta.
times f of theta.
Right. If I want
Right. If I
to
want
find the
to
critical
find the
radius,
critical radius,
again it's
again it's
same because
same because
the surface tension
the
is
surface
different, right?
tension
It
is
doesn't
different,
depend.
right? It doesn't depend.
It doesn't have any
It doesn't
function.
have any
This
function.
function
This
does not have
function
any
doesn't
terms
have
of r.
any terms of
So
r.
this is not
So
equals
this
to
is not
0
equals
again.
to zero again.
With equals to 0,
With
that's the
equals to
total
zero,
wetting
that's the
property,
total
which is
wetting
not
property,
ideal
which is
case.
not ideal case.
So
So
r star will be
r star will be
minus 2
minus
gamma
2
SL
gamma
by
SL by
delta G.
delta GB.
Again, we will arrive
Again,
at the
we will
same term,
arrive at the same term,
the r star,
the r star,
right?
right?
So
So
accordingly, you will
accordingly,
get
you will
the
get
delta G
the
star too,
delta G star too,
right? You just have to
right? You just
substitute
have to
r in that,
substitute r
and
in
you
that,
will
and
have
you will have
some relation,
some
but you
relation,
have this
but you
f of
have
theta
this
term
f of theta
here,
term here,
right? So
right? So
that's all about
that's all about
this guy.
this
Now,
guy. Now,
what happens if
what happens if
we are only talking
we are
about
only
the
talking
mold,
about the
right?
mold,
So
right?
the
So
nucleation is
the
happening
nucleation is
only on the
happening
one part.
only on
Now
the
what
one part.
happens
Now, what
at
happens
the
at the
grain boundary,
grain boundary?
right?
Right? On
The
grain
grain
boundary,
boundary
the
will be
grain
shared by
boundary will
two
be
grains.
shared by two
So
grains.
there are
So
planes,
there are
right?
planes,
One plane is
right?
shared.
One plane is shared.
So
So
I can have like
I
this.
can have like
So
this.
this is also
So this
possible.
is also
This is
possible.
possible in
This is
grains,
possible in
right?
grains,
So
right? So
if I draw this,
if I
then
draw
it will
this,
look
then it will look
more like this.
more like
So
this. So
let's say if
let's
this is my
say if
phase
this is
diagram.
my phase diagram.
So this is my
So
phase
this is
diagram.
my phase diagram.
Now
Okay.
I have
Now I
one
have one
phase alpha
phase
and
alpha
I have
and I
another
have
phase
another phase
beta. When I'm
beta.
trying to
When I'm
cool
trying
from
to cool
alpha to
from
beta,
alpha to
so
beta,
the beta will
so the
nucleate
beta will
from
nucleate
alpha, and
from
where it will
alpha, and where
nucleate,
it
it will
will
nucleate
nucleate,
from
it will
grain
nucleate
boundaries,
from grain
right?
boundaries,
So
right? So
let's say this is my
let's say
beta
this is my
and this
beta
is my
and
alpha,
this is my alpha,
right? Again,
right?
if I
Again, if I
represent
represent
the
the
equilibrium free
equilibrium
energy or
free
the
energy or
equilibrium
the
surface
equilibrium
energy
surface
terms,
energy
then
terms,
this will look
then
like
this
this.
will look like
So
this. So
before
so
nucleation,
before nucleation,
it's just
it's just
alpha
alpha
at
and
both
alpha
sides.
at both sides.
So you have
So you have
only
only
gamma
gamma
alpha alpha.
alpha alpha.
So the free energy,
So
the
the free
interface
energy, the
energy
interface
between
energy
two
between
two
two
grains,
two
okay,
grains, okay,
of same phase.
of same phase.
Now this is
Now
before
this is before
nucleation.
nucleation. What about after nucleation? You have two cups here,
right?
right? So
Let me draw
let
this
me draw this
here.
here.
So at this
So
point,
at this point,
right? So at this
right?
point
So
we
at this
have
point we have
the free energy
the free
between
energy
the
between
interface
the
energy
interface
between
energy between
the interface
the
surface energy
interface surface
between
energy between
alpha
alpha
and
and
beta.
beta.
The same goes
The
here.
same goes here.
Alpha,
Alpha,
beta,
beta.
and the surface
And the
tension
surface
or the
tension or the
contact angle will be
contact angle
theta.
will be theta.
Now
Now
we have another
we have another
interface energy
interface
which is
energy which is
gamma alpha
gamma alpha alpha.
So now,
So
for
now
equilibrium
for
condition,
equilibrium
to maintain
condition
this
to
shape,
maintain this
the
shape,
surface energy
the
must be
surface energy
balanced.
must be balanced, right?
So that will be
So
equals to
that will be
gamma
equals to
alpha
gamma alpha alpha
will be equals to
will be equals to
2 times
2
gamma
times gamma
alpha beta
alpha beta
cos theta.
cos theta.
This is again
This is again
a different
a
relation when
different
compared
relation
to
when
the
compared
previous
to
one,
the previous one,
right?
right?
Now,
Now,
now if I
now
try
if
to
I
write
try to write
total
total
energy will
energy
be equals to
will be equals to
minus.
minus.
Now we have
Now
two
we
volume
have two
caps,
volume
right?
caps,
Before we
right?
have only
Before
one
we have
volume
only
cap.
one
Now we
volume
have
cap.
two
Now
volume
we
caps.
have two volume
One,
caps. One,
two.
two.
Again, if you try to
Again, if you
derive
try
it,
to
it
derive
will
it,
just
it will just
come two times.
come two
Okay.
times. Okay.
Delta G V,
Delta GV,
volumetric free energy,
volumetric free
which is
energy,
coming from
which is
here.
coming from here.
The G versus T
The G
temperature,
versus T temperature,
right?
right? Or
It should more look
it
like
should
this.
more look like this.
This is
This
the
is let's say this is my
GS and this is my
GS and this
GL.
is my GL
This is my
and
melting
this is
point.
my melting point.
GL and
GL and
SGS.
SGS.
Before
Before
we have
we have
GS is
GS
less than
is less
GL
than GL
below melting point.
below melting point.
Now
Now
plus
plus
2 times
2 times
area of caps,
area of caps,
top surface
top
area
surface area
times gamma
times gamma
alpha
alpha
beta
beta
minus,
minus,
and
and also you have
this, let's say this is
this,
my
let's say this
beta,
is my
and
beta,
you also
then
have
you also have
gamma.
gamma. Yeah.
No, let's not
So
take
let's
this
not
because
take
this
this
is
because
covered,
this
right?
is
This
covered, right?
the whole
This
part is
the
taken.
whole part is taken.
So minus,
So minus,
what is the
what is the
interface energy
the interface
that
energy
has been
that
destroyed
has been
will be
destroyed
equals to
will be equals to
gamma
gamma
alpha alpha
alpha alpha
times area
times
of
area of
bottom one,
bottom one,
right? The bottom of the
right?
cap.
The bottom of the cap.
So
So
bottom of
bottom of
cap.
yeah.
Now
Now
what is that volume?
what is that volume? We
We know
know
4 by 3
4 by
pi
3
r
pi
cube
r cube
2
2
times f of theta,
times f of theta,
right?
right?
Plus this is
Plus
minus.
this is minus.
Now what is my
Now
AC?
what is my AC?
Pi r square
Pi r square
1 minus
1
cos theta,
minus cos theta.
and also this
And also this
2 caps,
2
so 2
caps.
times that
So 2
area
times that area
times gamma
times gamma
alpha
alpha beta
minus
minus
pi r
pi
square
r
sin
square
square
sine
theta
square theta
gamma
gamma
alpha alpha.
alpha alpha.
So now
So now
the volumetric
the
term is simple.
volumetric term
It's
is
just
simple. It's just
2 times
2
that
times
volume.
that
Now
volume.
the area
Now the
part
area part
will have
will have
2 pi r
2
square
pi r square
gamma alpha
gamma
beta
alpha
minus
beta
2 pi
minus
r
2 pi
square
r square
cos theta
cos
gamma
theta
alpha
gamma
beta.
alpha beta.
So
So what is my area term here? Let me check the area term. Yeah, it is 2 pi r square 1 minus cos theta, so it will become 4 pi r square. Yeah, so this will become times 2 because it will, we have two surface area, right? So it will become 2 times. Now everything will become 4. So it will be 4 pi r square, 4 pi r square minus pi r square sine square theta. What is my gamma alpha alpha? Which is 2 times gamma alpha beta cos theta. So sine square theta again, writing everything in terms of cos square theta. So it will be 1 minus cos square theta, 4 pi r square gamma alpha beta minus 4 pi r square cos theta interface energy alpha beta minus pi r square 2 pi r square gamma alpha beta cos cube theta. Minus into minus will become plus, and you have minus 2 pi r square cos theta gamma alpha beta. So this term and this term will get added. I will remind with the volume term 4 pi r square gamma alpha beta minus yeah. So 8, no, it's not 8, it's 6, right? So it's 6 6 pi r square cos theta gamma alpha beta plus 4 pi r square cos cube theta gamma alpha beta. If I take 4 pi r square and interface energy of alpha beta is common, then no, let's take 2 pi r square. That will be more appreciable. So 2 pi r square gamma alpha beta times 2 minus 3 cos theta plus cos cube theta. Oh, there is no pi 4 here because you won't be getting any 4. You get 2, right? So we'll get common now. Again, if I divide by 4 and multiply by 4, so 4 minus 4 by 3 pi r cube times 2 times f of theta. There is this 2 term. Same here, 4 pi r square times 2 f of theta. So delta G heterogeneous at grain boundary, right? If I take common 2 f of theta, which will turn out to be 4 by 3 pi r cube plus 4 pi r square as common times 2 f of theta. So these are final expression for grain boundary. The heterogeneous nucleation at grain boundary. Now, what does it imply? So delta G heterogeneous, delta G homogeneous with 2 times f of theta.
This is for
This is for
at grain
at
boundary.
grain boundary.
Right. Now
Right. Now
the same
the
thing
same
you
thing
can derive it
you
for.
can derive it for.
This is
This
for
is for
the grain
the
boundary
grain boundary
derivation,
derivation,
where we
where
have
we have
the two
the
times.
two times.
Right. Now
Right.
what
Now what
happens if
happens
at
if at
the
the
grain
grain on the
three grains are
three grains
meeting?
are meeting?
Now
Now how it will look like?
so
So
if this is
if
my,
this is my,
the
let's
top
say, the
view,
top view,
this is my
this is
grain
my
1,
grain
this is
1,
my
this is
grain
my
2,
grain
this
2,
is
this is
my
my
grain 3.
grain 3.
Let's say three
Let's say
grains are
three grains
meeting
are
at
meeting
one
at
point.
one point.
This is my
This is my
meeting point.
meeting point.
Now how
Now
does
how do
they look
they
like?
look like?
Let's say
Let's say
this is
this
my,
is my,
these three
these
grains
three
have
grains have
alpha phases.
alpha
Let's say
phases. Let's say
this is my alpha
this
phase,
is my
this is
alpha
my alpha
phase, this
phase,
is my
and this is
alpha
also
phase, and
my
this is
alpha
also my
phase.
alpha
Now
phase. Now,
if there is a
if there
growing
is a
of
growing of
caps, then
caps,
they will
then
look like
they will
this.
look like this.
Right. You can
Right.
even
You
derive
can
for
even derive for
this one also.
this one also.
And whatever at
And what
corners.
about at corners?
So corners
So
is a little
corners
bit
is a
complex.
little bit complex.
Then the
And
grain
the
is
grain
here.
is here
At grain boundary,
at grain boundary.
the grain
The
boundary
grain
shares a
boundary
plane.
shares a plane,
Right. But
right?
here
But
the three
here
grains
the three
share
grains
a point,
share
a
a
line.
point, a line.
At, if
At
four
if
grains are
four
meeting at
grains are meeting at
four
four
grains are meeting,
grains are meeting,
then their
then their
intersection
intersection
is a point.
is a point.
This is one point.
This is one point.
Okay.
Okay.
Yeah.
Yeah.
So what does this
So what
imply?
does this imply?
It implies
It
means the
implies means the
heterogeneous barrier
heterogeneous
is
barrier
doubled
is doubled
when compared
when
to
compared
the
to
nucleation
the
on mold.
nucleation on mold.
Right.
Right.
Now,
Now,
if we
if
try to
we try to
draw a plot,
draw a plot,
okay,
okay,
let's say this is
let's
my
say this
delta
is
G
my delta G
heterogeneous,
heterogeneous,
and this is my
and this is my
delta G
delta G
homogeneous.
homogeneous.
This is my 1
This is
where
my
the
one,
both are
where
equal.
the both are equal.
And this is my
And
gamma
this is
alpha alpha times gamma alpha beta. So it will more or less look like this. Okay.
okay.
So it will more or
So
less
it will
look like
more or
this.
less look like this,
Right.
right?
Now,
Now,
what are these three
what
ones?
are these
This
three
is
ones?
for
This is for
grain
grain
boundary,
boundary,
or two grains are
or two
meeting.
grains are meeting.
Here
Here
you have
you
three
have
grains are
three
meeting.
grains are meeting.
Here you have
Here
four
you have
grains are
four
meeting.
grains are meeting.
Right.
Right.
This is
This is
one point.
one
Here
point.
you have a
Here you
line.
have a line.
Here you have
Here you
plane
have
sharing.
plane sharing.
Right. Now what is
Right.
my
Now
gamma
what is my
alpha,
gamma
alpha by
alpha
gamma alpha
alpha by
beta?
gamma alpha beta?
Which is 2
Which
cos
is
theta.
2 cos theta.
Now what is happening?
Now what is
If
happening? Now
it
if
increases,
it increases,
then that means
then that means
the gamma
the
alpha
gamma
beta
alpha beta
has less
has
uh,
less energy,
interface energy.
interface energy.
Right.
Right.
So at that
So
point,
at that point,
everyone is equal.
everyone is equal.
Right. So these
Right. So
three
these
point will
3 point
converge
will
at
converge
higher
at
values
higher values
at one point.
at one point.
Now
Now
that means the
that
grain
means the
boundary
grain
and the three
boundary and
grains
the
are
three
meeting, or the
grains are
four
meeting, or
grains
the
on the
four
green
grains on the
corners
green corners
will have
will have
will nucleate.
will nucleate.
Right. Will have
Right.
same
Will
delta
have same delta
heterogeneous value.
heterogeneous value.
Now if I try to
Now if I
decrease
try to decrease
this gamma alpha by
this
gamma
gamma
alpha
alpha by
beta, that
gamma alpha
means
beta,
the
that means
interface
the
energy of
interface
gamma alpha
energy of
beta is
gamma alpha
increasing.
beta is increasing.
Which means the interface
Which
energy
means the
of
interface energy
gamma
of
alpha beta is
gamma alpha
increasing.
beta is increasing.
That means
That means
the four
the
grains
four grains
to reduce
to
the gamma
reduce
alpha
the
beta,
gamma alpha beta,
right? The system
right? The
will try
system
to
will try to
have this one. So
have this
four
part. So
grains
four grains
are the point
are the
where the four
point
grains
where
are
the four
meeting.
grains are
From
meeting.
that point,
From that point,
let's say
I'd say
the grain will
the
nucleate.
grain will nucleate.
Right. So
Right. So
that is about
that is about
this nucleation
this
part.
nucleation part.
Now,
Now,
how do
how do
yeah? Let's coming
yeah?
to
Let's coming to
the
the
rate of nucleation.
rate of nucleation.
Right.
Right.
Now,
Now,
we know the
we
nucleation
know
will
the
start
nucleation will
once
start
you
once
attain
you attain
critical radius. On
critical
that critical
radius. On that
radius,
critical radius,
your nuclei will
your
start
nuclei
growing.
will start growing.
Right. Once the
Right.
nucleation
Once the
starts,
nucleation
once it
starts and
reaches
once it reaches
critical
the
radius,
critical
then
radius,
it
then
will start
it
growing.
will start
So
growing.
that is our
So that is
ideal
our
case.
ideal case.
Now we need to
Now
find.
we need to
Suppose
find, suppose
we have a
we
system
have a
and we
system
have
and we
we
have
cool
we
and in the
cool
system
and in the
contains the
system
liquid
contains
melt.
the liquid melt.
Okay, and when we
Okay,
try to
and when
cool
we
it,
try to cool it,
there will be
there
formation
will
of
be formation of
nucleus.
nucleus.
You'll have a
You'll
clusters,
have a
the
clusters,
nucleus
the
formation.
nucleus formation.
Right, and we
Right,
need to
and we
find what are
need
the
to find
critical
what are the critical
nuclei such that
nuclei such
they
that
will start
they will
growing.
start growing.
Now,
Now,
for homogeneous
for
nucleation,
homogeneous nucleation,
right? So let's
right?
write
So
for
let's write for um,
homogeneous nucleation
homogeneous
will be
nucleation
equals
will
to,
be equals to,
it will depend
it
upon
will depend upon
first
first
what is the
what is the
probability
probability
of finding
of
that
finding
one, right?
that
So
one,
that will be
right? So
equals
that
to
will be equals to
delta
delta
G star by
G star by
KT.
KT.
Is my
Is my Boltzmann
Boltzmann
equation. So
probability
Boltzmann probability
times.
times.
Now,
Now,
once my critical
once my
nuclei
critical
forms,
nuclei forms,
right,
right,
it has to
it has
change
to
its radius
change
from
its
critical
radius from
nuclei.
critical
It should
nuclei.
be R
It
must
should
be
be
greater
R
than R
must be
star.
greater than R
So
star.
what
So
I'm trying to do
what
is
I'm trying to do is
one liquid atom
one liquid
will try
atom
to
will
jump
try to jump
into this nuclei
into
and
this
get
nuclei
attached to
and
it.
get attached
So
to it.
its size
So its
increases.
size increases.
So we need to
So we
find,
need to
we need
find,
to know what
we
is the
need to know
jump
what is the
frequency
jump
that will
frequency
be given
that
by
will be
the
given by
successful
the
jump
successful
frequency,
jump
which
frequency,
is
which is
gamma,
gamma,
and
and
the C naught,
the C naught,
the total number of
the total
nucleation
number of
sites.
nucleation sites.
Right.
Right.
So this is my
So this is my
n homogeneous
n
nucleation,
homogeneous nucleation,
which is given by
which is given by
this.
this.
Right. If I try to
Right. If I
substitute
try
what
to
is my
substitute
delta
what is
G
my delta
in
G
terms of
in terms of
delta T,
delta T,
which can be derived.
which can be
Now,
derived. Now,
what about
what
heterogeneous?
about heterogeneous?
Right. Which is
Right,
like again
which is like
jump
again
frequency
jump
times
frequency
e
times
power
e power
minus delta
minus
G
delta G
upon KT.
upon
This
KT,
is for
which is
heterogeneous.
for heterogeneous.
Both the delta G
Both the
heterogeneous
delta G
and delta G
heterogeneous and
homogeneous
delta G
are not same.
homogeneous, which are not
And
same.
here we will
And
have
here
C.
we will have C.
Why? Because
Why? Because
the sites are not
the
same.
sites are
The
not same.
homogeneous
The
sites and
homogeneous
heterogeneous
sites and
sites are not
heterogeneous
same.
sites are not
So
same.
that's why it is
So that's why
different.
it is different.
Right.
Right.
Now we know the
Now
delta
we
G
know the delta G
heterogeneous is
heterogeneous
less
is
smaller when
less
compared to
smaller when
delta G
compared to delta
homogeneous.
G
And
homogeneous.
we even know the
We
relation
even know the
delta G
relation delta
heterogeneous
G
will be equals
heterogeneous
to
will be equals
f
to
of theta
f of theta
delta G
delta G
homogeneous.
homogeneous.
And this is
And this is
lies between
lies
0 to
between
1.
0 to
So
1.
that means
So
this
that
is
means this is
less than
less
delta
than
G
delta
homogeneous.
G homogeneous.
Now that's why
Now that's why
at a certain
at a certain
undercooling they
undercooling
will shoot up
they will
when
shoot up
compared to
when compared to
delta G
delta
homogeneous.
G
It
homogeneous.
requires a
It
large
requires a
undercooling
large
when compared
undercooling
to
when compared to
delta G
delta
homogeneous.
G
Even delta G
homogeneous. Delta
heterogeneous,
G
right? It
heterogeneous.
requires
Right? It
less
requires less
undercooling when compared to
undercooling when
homogeneous
compared to
nucleation.
homogeneous nucleation.
Now that is all
Now
about
that is all about
nucleation. Now
nucleation.
next part
Now
is
next
the
part
growth.
is the growth.
Right.
Right.
Now we have talked
Now
a
we
lot
have
about
talked a lot about
growth,
the growth,
nucleation. Now it is
nucleation.
about
Now it
the
is
growth.
about the growth.
So how growth
So
happens?
how growth
Growth happens
happens?
from
Growth
the
happens
interface.
from the
Let's say,
interface. Let's say,
uh,
uh,
let me add a
let me
slide.
add a slide. Yeah.
Growth
Growth
happens
happens
from interface.
from interface
At
at
interface.
interface. You know.
So let's say
So let's say
I have
I
solid
have solid
and liquid.
and liquid.
Right. Now what I'm
Right.
trying
Now
to
what
do
I'm
is I'm
trying to do
trying
is
to
I'm trying
cool
to
this
cool
liquid.
this liquid.
Right.
Right.
Initially it was hot.
Initially it
Now
was hot.
what I'm
Now
trying to do?
what I'm
I'm
trying to
trying
do,
to cool
I'm
this
trying to
liquid.
cool
Now
this
what I'm
liquid.
trying
Now
to do
what
is
I'm
I'm
trying to
trying to
do is I'm
extract
trying to
heat
extract heat
from solid.
from solid.
Okay. So what
Okay.
happens is,
So what happens
but this
is,
part
but
is
this part
hot.
is hot,
But this part is
but
cold.
this part is cold.
Let's say this is our
Let's say
scenario.
this is our scenario.
Okay.
Okay.
Now
Now,
if I try to
if I
extract
try
heat
to
from
extract
solid
heat
part,
from
then
solid part,
the heat will
then the
flow
heat
in
will
this
flow
direction.
in this direction.
Right. So
Right.
let's say
So let's
this
say
is at
this is at
Tm, the
Tm,
melting
the
temperature.
melting temperature.
Right.
Right.
So this is
So this
T1,
is
T2,
T1, T2,
T3,
T3,
and T4.
and T4.
Okay. So
Okay. So
T1 is less
T1
than,
is less
T2 is
than,
less
T2
than
is less
T3.
than, Tm, then T3.
Right. So
Right. So
T4 will have
T4 will have
higher temperature,
higher
the max
temperature, the
temperature.
max temperature.
Right. So as the
Right.
heat
So
is
as the
being
heat is
extracted,
being extracted,
now
now
this is at time
this is at
T
time
equals to
T
T1.
equals to
Now what
T1.
happens at
Now what
time
happens at
T equals
time
to
T equals
T2?
to T2?
This is my solid,
This
this
is my
is my
solid,
liquid.
this is my liquid.
So it is
So
at
it is
x
at
equals to
x
1.
equals to
Now
1.
we have
Now
reached
we have
x
reached
equals to 2.
x equals to
The
2.
interface
The
will start
interface will start
moving.
moving.
Right. Then that
Right.
means
Then that means
this portion,
this portion,
this portion of
this
liquid
portion of liquid
will get
will get
solidified.
solidified.
Right. If I try to
Right. If I
extract
try to
more and more
extract
amount
more
of
and
heat,
more
then
amount of
this
heat,
Tm
then this
will
Tm
the
will
temperature
the
at
temperature
interface
at
will again go
interface
down.
will again go down.
Right. Less than
Right.
Tm.
Less
So
than
that's why
Tm. So
again
that's why
the
again
liquid
the
will
liquid will
form here.
form
So
here.
that's
So
how the
that's
solid
how the
liquid
solid
interface will
liquid
move.
interface will move.
Now we need to
Now
know
we
how,
need to know how,
what are the kinetics
what are
part.
the
Now how
kinetics part.
this
Now how
physically
this
happens.
physically
Can we
happens. Can we
mathematically
mathematically
have a relation with
have a
how this
relation with how this
interface move?
interface move?
So
So
yeah.
yeah.
So that is how
So that is how
we arrive to the
we
growth part.
arrive to the growth
Now
part. Now
to before
to before
going into the growth
going
part,
into the growth
we
part,
need to know
we need to know
what are the different
what are the
types of
different types of
solid liquid
solid
interfaces
liquid
we can find.
interfaces we can find.
Right. So majorly we
Right. So
can
majorly we
come up with
can
two
come up
types.
with two types.
One is
One
smooth,
is smooth in
smooth,
smooth. One
smooth
is smooth
solid liquid
solid
interface,
liquid interface,
or you can call
or
it
you
as
can call it as
atomistically smooth,
atomistically smooth,
or
or
atomistically smooth,
atomistically smooth,
or sharp
or sharp
solid liquid
solid
interface.
liquid
And
interface.
the next one
And
is
the next one is
rough,
rough,
atomistically rough, or
atomistically rough, or
diffused interface,
diffused interface,
diffused
diffused
solid liquid
solid liquid
interface.
interface.
Right. So these are
Right.
the
So
two
these
types
are
of
the two types of
solid liquid
solid
interfaces.
liquid interfaces.
Okay.
Okay.
Now,
Now,
so
so yeah,
these are the
these are the two types of
solid liquid
solid liquid
interfaces
interfaces
you will find.
you will find.
Now,
Now,
because of the
because of
differences
the
in
differences
atomic
in
structure,
atomic structure,
right? So
right? So
liquid
liquid
has a random
has
movement
a
of
random
atoms,
movement
but
of atoms,
the
but
solid
the solid
it doesn't have
it
that. So
doesn't have that.
entropy of
So
liquid
entropy
is
of
much more
liquid
when
is much
compared
more
to
when
entropy
compared
of
to
solid.
entropy of
That
solid.
means
That means
in
in
solid
solid
the
the
atoms
atoms
cannot
cannot
move
move
freely
freely
when compared to a
when
liquid.
compared to a liquid,
And some
and
solids
some
have a definite
solids
crystal
have definite
structures,
crystal
right? So
structures, right?
because
So
of the
because of
differences in
the differences in
structure,
atomic
these
structure,
two types of
these two types
interface
of
migrate
interface
in
migrate
quite
in
different
quite
ways,
different
right?
ways,
So
right?
rough
So rough
interfaces can
interfaces
migrate
can migrate
by
by
the continuous
the
growth process,
continuous growth
which I will
process,
explain
which I will
in a
explain
few minutes,
in a
and
few
then
minutes,
we
and
have the
then
flat
we have the
interfaces
flat interfaces
or the
or
atomistically
the
smooth
atomistically
interfaces,
smooth
and
interfaces,
they migrate
and
by
they migrate
either
by either
lateral growth process.
lateral growth
Okay,
process.
so
Okay, so
before going into
before going into
smooth one,
smooth one,
let's derive
let's derive
the
the
what is the solid
what is
speed at
the
which
speed at
the
which
solid or
the
liquid
solid or
interface
liquid
will grow
interface will grow
for the rough
for the rough
interfaces. Now,
interfaces. Now,
let's say
let's say
this is my
this is my
solid
solid
solid,
this is my solid,
and this is my
and this is my
liquid.
liquid. Fine.
Let me draw those
Let me
atoms.
draw those atoms.
Let's say
Let's say
these are my
these are my
liquid atoms.
liquid atoms. Uh,
This
we
one.
like this one.
So there is no
So there is no
arrangement of atoms
arrangement
here,
of atoms
right?
here, right?
Because all
Because
the
all the
atoms in
atoms in
liquid are
liquid are
randomly moving,
randomly moving,
randomly colliding
colliding
with
with
another
another
atoms.
atoms.
But
But
whereas
whereas
in
in surface,
solid atoms,
solid
let's
atoms, let's
write it in terms
write
of
it
like
in terms of like
more
more
arranged,
arranged,
right?
right?
So
So
they are more
they are
arranged when
more
compared
arranged
to
when compared to
liquid atoms.
liquid atoms.
Right? You can
Right?
see
You can
the
see
arrangement,
the
right?
arrangement, right?
So
So
there is no
there
breaking
is
of
no
symmetry
breaking
here.
of symmetry
It's
here.
just
It's just a
explanatory diagrams.
explanatory diagram. So
You can see
we can see
the
the
atoms
atoms
are
are
correctly
correctly
arranged,
arranged,
but
but
when
when
compared to
compared to
here,
here,
which is not the
which
case.
is not the case.
Here it is
Here
different.
it is different.
Here it is
Here
different.
it is different.
Right, and
Right?
this can
And
be
this can be
more
more
to derive this.
to derive this.
Let's say this is my
Let's say this
interface,
is my interface, right?
solid
Solid
liquid interface.
liquid
Now, if you
interface.
want to
Now, if
know
you want
how
to
the
know
velocity
how the velocity
of the solid
of the solid
interface
liquid interface
grow with respect to
grow
the
with
time,
respect to the
right?
time,
I'm
right?
extracting
I'm
heat
extracting heat
from solid.
from solid.
How this will grow?
How this will grow?
That is
That is
the condition
the
we need to
condition
find.
we need to find.
Now,
Now,
this can be
this
more
can
or
be
less can
more
be
or
treated
less
as
can be treated as
the movement
the
of high
movement
angle
of
grain
high
boundary
angle grain
or the
boundary
random
or the random
high
high
angle
angle
grain
grain
boundary,
boundary,
right?
right?
So this can be
So
more
this can be
related to the
more related to the
random high angle
random
grain
high
boundary
angle grain
because
boundary because
grain
at
boundaries the
grain
atoms
boundaries
are
the
more
atoms are
randomly
more randomly
arranged when
arranged
compared to
when compared
inside the
to
grains,
inside the grains,
right? Because of
right?
grain
Because of
boundary you do
grain
not have
boundary you
any
do not have any uh,
like symmetry
like
when
symmetry
compared to
when compared to
the symmetrical
the
arrangement of
symmetrical
atoms
arrangement of
in grains,
atoms in grains,
right?
right?
Now,
Now,
how do we derive
how
that?
do we derive that?
Let's say
Let's say
this is my
this is my
interface,
interface,
right? This is my
right?
G1,
This is my
this is
G1,
my G2,
this is my G2.
or now we
Or
can take
now
it
we
as
can take it
solid
as
and liquid,
solid and
which can
liquid,
be
which
equated
can be equated
to solid and
to
liquid,
solid and liquid,
right?
right?
Now,
Now,
what is my flux?
what is my
What is
flux?
my flux of
That is my
atoms,
flux of atoms,
right? Now,
right? Now,
if I draw
if
the
I
free
draw
energy
the free energy
versus distance
versus
diagram
distance
or the energy
diagram or the
versus
energy
distance
versus
diagram,
distance diagram,
so
so
the solid
the solid
has less
has
free energy
less free
when
energy
compared to
when compared to
liquid
liquid
below melting point,
below melting point,
right?
right?
And
And
if the atom
if the
wants
atom
to jump
wants to jump
from solid to
from
liquid,
solid to liquid,
right? Just
right?
like here,
Just
if
like
it
here,
wants to
if
jump
it
from
wants to
solid
jump from
or
solid
liquid
or
to solid,
liquid to solid,
it needs to
it
cross a
needs to
barrier,
cross a barrier,
right? So that is
right? So
given by,
that is given by,
let's say,
let's say,
so
so
this is
this
the
is
barrier
the
it needs to
barrier it
cross,
needs to cross.
and this is the
And
free
this
energy
is the free
difference
energy
between
difference between
solid and liquid.
solid and liquid.
The free energy difference
The free
between
energy
solid and
difference
liquid,
between solid and
and there
liquid.
is the
And
energy,
there is the energy that
the jump
the jump
frequency or the
frequency or the energy successful jump barrier that atom needs to
from
cross
solid to
and from
liquid.
solid to
So
liquid. So
the first one that
the
is
first
coming
one
will
that
be
is coming will be
the
the
frequency
frequency
times
times
exponential.
exponential.
If an atom is
If an
trying
atom
to
is
jump
trying
from
to jump
solid to
from
liquid, we
solid
can
to
have two
liquid, we
cases,
can
right?
have two
We can
cases,
have
right? We
either
can
solid
have
to
either
liquid or
solid to
liquid to
liquid or
solid,
liquid to solid,
right? So this is
right? So this is
liquid to solid,
liquid
and
to
this is
solid,
solid
and
to
this is
liquid.
solid to liquid.
Let's say what I'm
Let's
trying
say
to do
what
for
I'm trying
solid
to
to
do for
liquid.
solid to liquid. right?
it
So
needs to
it
cross
needs to
the
cross
whole
the
energy,
whole energy,
right? So
right?
that will be
So that will be
delta
delta
G
G
star
star
plus
plus
delta G
delta G
SL
SL
upon
upon
KT
KT
times
times
the number of
the
atoms
number of atoms
at plane 1.
at plane 1.
Frequency of
The
atoms
frequency
jumping
of
from
atoms jumping from
solid to liquid.
solid to liquid.
So successful
The
frequency
successful
times the
frequency
number of
times the
atoms
number of atoms
or the planar
or the
density
planar density
at 1.
at 1.
And there is also
And
this,
there is also this,
the accommodation
the
factor,
accommodation factor,
right? So this
right? So this
accommodation factor
accommodation
tells us
factor tells us
that
that
the atom,
the atom,
okay, if the
if
atom tries
the
to jump
atom
from
tries
one
to
plane
jump
to
from
another
one
plane,
plane to another
can
plane,
it be
can it be
sit random,
sit
sit
random,
comfortably
sit
there,
comfortably there,
right? Without any
right? Without
objection
any
coming from
objection coming
the plane
from
2,
the plane
right?
2,
Suppose
right? Suppose
if I have
if I
plane
have
1
plane
and
1
I have
and
plane
I
2,
have plane
the
2.
atoms are
Now
trying to
atoms are
jump from
trying to
plane 1
jump
to
from
plane 2.
plane 1 to plane
Now
2.
what does the
Now what
accommodation
does the
factor?
accommodation factor?
Tells
Accommodation
that
factor tells
how
that
easily that
how
atom
easily that
that jumping
atom
from
that
plane
jumping
1
from
can be
plane 1
accommodated
can be
into plane 2.
accommodated into plane 2.
So it's just the
So it's just
probability.
the probability.
Now,
Now
what about
what about
liquid to solid?
liquid to
That
solid?
will be equals
That will
to
be equals to
accommodation
accommodation
factor
factor
at
at
solid plane
solid plane
times the number of
times the number of
atoms, the planar
atoms, the
density
planar density
of
of
liquid plane
liquid
times
plane
the
times
successful
the
jump
successful
frequency
jump frequency
into the
into the
exponential term,
exponential term,
then minus
yeah,
you'll have
minus you'll have
delta G star
delta G
upon
star
KT.
upon KT.
So all
So
I
all
need to
I
travel
need to travel
is only this
is
part.
only this part.
Once I
Once I
once I can
once I can
reach this
reach
point,
this point,
I can easily
I
hold on
can
because
easily
this is the
hold on
most
because this
favorable
is the
part.
most
I do not
favorable
have
part.
to
I
jump
do not
this one
have to
because
jump
I'm
this one because
already
I'm
above
already
this one,
above this one,
right? So
right?
all I have to do
So
is
all
I
I have
have
to do
to
is I have to
only pass the
only
barrier
pass
of
the
delta G
barrier of
star.
delta G star.
But when atoms
But
are
when
trying
atoms are
to
trying
jump from
to
solid to
jump from
liquid,
solid to liquid,
they even have to
they
try
even have to try
jump this barrier
jump
also.
this
So the
barrier
barrier
also. So the
becomes
barrier becomes
increased when compared
increased
to
when
the
compared
atoms
to
jumping from
atoms
liquid to
jumping from
solid,
liquid to solid.
right? It just
Right?
once
It
there is
just
this
once
stop
there is
point,
this stop point,
they can easily
they can
slide,
easily slide down.
right? So
Right? So
what is my net
what
flux?
is my net flux?
J net
J net
will be equals
will
to,
be equals to,
let's say
let's say
JLS is
JLS
greater than
is greater
JSL,
than JSL,
right?
right?
So you can easily
So you
see
can
because the
easily see
barriers, because of
because of the amount of
that is
barrier
being
that is being
seen here,
seen here,
right? So
right?
JSL,
So
so the
JSL,
atoms that
so
are
the
trying to
atoms that are
jump from
trying to
solid to
jump from
liquid, they
solid
need
to
to have
liquid, they
higher
need to
amount of
have higher
energy
amount of
when
energy
compared to
when compared
atoms
to atoms
jumping
are
from liquid to
jumping from
solid,
liquid to
right?
solid,
So the net
right? So
flux
the
will be
net flux will be
from liquid to
from
solid
liquid to
rather than
solid
solid to
rather than
liquid.
solid to
So
liquid. So
JLS minus
JLS minus
JSL
JSL
will equals to
will be equals to
A1
A1
into
into
gamma 2
gamma 2
times e power
times e power
exponential
exponential
minus delta
minus
G
delta
star
G
upon
star
KT
upon KT
minus
minus
A2
A2
N1 gamma
N1 gamma
e
1
power
e
minus
power minus
delta G
delta
star
G star
upon KT
upon KT
times delta
times delta
GV upon
GV
KT
upon KT
or delta
or
GSL
delta
upon
GSL
KT,
upon KT,
right? Now,
right? Now,
let's continue.
let's continue.
Let's
Let's
say
say
the
the
accommodation
accommodation
factor
factor
is
is
1.
1.
The
The
probability
probability,
like
like the
the,
accommodation,
if an atom
if
tries
an
to
atom
jump
tries
from
to
plane
jump
1 to
from
plane
plane
2,
1 to
it can
plane
be
2,
easily
it can be
accommodated
easily
in plane 2,
accommodated in plane 2,
right? So
right? So
A1 will be equals
A1 will
to
be equals
A2
to
will be equals
A2
to
will
1,
be equals to 1,
right? Which is not
right? Which is
an
not
ideal case,
the
but for
ideal case, but
simplicity we
for
are just
simplicity, we are
considering
just
this
considering this
relation.
relation.
And the next part
And the
is
next part is
the amount of
the
jumps.
amount of jumps.
Let's say at
Let's say
equilibrium.
at equilibrium.
At equilibrium, we
At
have delta
equilibrium,
G
we have
equals to
delta
0.
G equals to
That means
0.
the number of
That means
atoms
the
jumping
number of
from 1
atoms
to
jumping
2
from 1 to
will be
2
equals to
will be equals
2
to
to 1,
2 to 1,
right? So
right?
that means
So that means the
the N1 gamma 1
N1
will be
gamma
equals
1
to
will be equals
N2
to
gamma 2,
N2 gamma 2,
which is
which is
A2
A2
A1,
A1,
right? So
right?
then
So then
for,
for,
let's say for
let's
just
say for just
the
the
quasi-statical,
quasi-statical,
let's
like
say they
let's
just
say they just let's say at equilibrium,
we just
we
changed
just
our free
changed
energy,
our
we just
free
supplied
energy.
some
We just
amount of
supplied some
energy,
amount of
very
energy,
little amount of
very little
energy.
amount of energy,
Then
right?
what
Then
happens?
what happens?
And for simplicity
And for
we assume
simplicity,
these
we assume
are
these
equal.
are equal.
So if I true to
So if I
minus,
true to
so
minus, so
let's we can take any
we
one.
can take any
So
one, right?
let's
So
take
let's
a2
take
n1
a2
gamma 1
n1 gamma 1
and taking
and taking
exponential
exponential
minus delta
minus
g star
delta g
upon
star
kt
upon
as a
kt
common.
as a common.
Then we are
Then
remained
we
with
are remained with
1 minus
1 minus
e power
e power
minus delta
minus
g
delta g
sl
sl
upon
upon
kt,
kt,
volumetric free energy,
volumetric free energy,
right, upon
right,
interpolate.
upon interpolate.
So
So
now
now,
using Taylor's
using
approximation
Taylor's
we can
approximation,
write
we can
e
write
power
e
minus
power
x
minus
will equals
x
to
will be
1
equals to
minus
1
x
minus x
upon 1
upon 1
factorial plus
factorial
x
plus
square
x
by 2
square by 2
factorial
factorial
minus x
minus
cubed by
x
3
cubed by 3
factorial. So
factorial.
let's
So let's
take out
take out
the higher order
the
terms
higher order
because
terms
they
because
will just
they
add
will just
1 to
add
3%
1
of
to
error.
3% of error.
So
So
a2
a2
n1 epsilon
n1
1
epsilon
times
1 times
e power
e
minus
power minus
delta
delta
g star.
g star. Let me write it. Yeah,
Epsilon 1
epsilon
times
1 times
e power
e power
minus
minus
delta g
delta
star
g
upon
star
kt
upon kt
times
times
1
1
minus
minus
delta g
delta
s
g
minus
s
l
minus
upon
l
kt,
upon kt. Or
we have
we have
minus, right? So
minus, right? So
it
it
will
will
be
be
1
1 plus
minus
minus 1.
1.
So
Minus 1
minus 1
will
get
get cancelled.
cancelled.
So
So
we
we
have
have remained
remained
with,
with,
let's
let's
say,
say,
this
this
whole
whole
term
term
as
as
m,
m, which
which
in
in
phase
phase
transformation
transformation
thing
thing
we
we
called
called
it
it
as
as a
a
mobility,
mobility term.
mobility term,
So
right?
m times
So m times
delta g
delta g
s l
s l
upon
upon
kt,
kt,
which is my
which is
flux.
my flux.
Now we can even
Now we can
simplify
even
this to
simplify
some
this
extent.
to some extent.
Let's say
Let's say
if we know
if we
the
know the
concentration and the velocity
concentration and the
with
velocity
which
which
the atoms are
the
moving,
atoms are moving,
the
the
interface plane is
interface
moving,
plane
then
is
it can be
moving, then
given
it
as
can be given
c
as
dot v.
c dot v.
Right? Here
Right?
v is
Here
the
v is
velocity.
the velocity.
Okay. Now c
Okay.
can be
Now c
represented
can be
as
represented
the
as
concentration,
the
the number of
concentration,
atoms
the
per
number
unit
of
volume,
atoms per unit
or
volume,
the
or
velocity
the velocity
times
times
volume
volume
upon n naught.
upon n naught,
Total volume upon n
total
naught,
volume
which
upon n
is
naught, which is
volume of
volume
atoms
of
or the
atoms
molar
or
volume.
the molar
Right?
volume,
We can
right? We can,
atomic
or
volume. You
atomic
can
volume,
represent as
you can
Vm.
represent as Vm,
This stuff.
this stuff,
Right. So if I
right?
try
So
to
if I
equate
try to equate
this to that,
this to
so
that, so
what is my j?
what is my J?
J is
J is
a2
A2
gamma 1
gamma 1
n1
and 1
exponential minus
exponential
delta
minus
g
delta
star
E
upon
star
kt
upon kt
times
times
delta g
delta g
sl upon
sl upon
kt,
kt,
which will be equals
which
to
will be
c
equals to
or
c or
velocity
velocity
upon v
upon
naught
v
n
naught
naught.
n naught.
Right. Now if I
Right.
try to
Now if I try
equate
to
this to
equate
that,
this to
so
that,
we know
so we
delta
know
sl
delta
will
sl
be equals
will
to
be equals to
delta h.
delta h.
Right. So
Right.
let's
So
try to
let's try to,
no.
you know,
So delta
so
h
delta
minus
h
t,
minus t,
delta sm
delta sm will be delta h
upon tm.
upon
So
tm.
delta
So
h if I
delta
take
h if I take
common, then
common,
delta
then
t
delta
upon
t
tm.
upon tm.
This is my
This
delta
is
g
my delta
sl.
g sl.
Now
Now,
if I try to
if I
substitute
try to
there,
substitute there,
this is my
this is
velocity
my velocity
a2 gamma 1
a2 gamma 1
e power
n1 e
minus
power
delta g
minus
star
delta g
upon
star
kt.
upon kt. It's
This term here
this term
times
here times
Vm atomic
Vm
volume.
atomic volume.
We have
We have
delta Hm
delta Hm
upon
upon delta T
on
upon
Tm
Tm
and
and
Kt,
Kt.
right? So
Right? So
this is my
this is
velocity.
my velocity.
Now if I take
Now, if I take
all these terms
all
of a
these
common,
terms of a
right?
common, right?
Like
Right.
this will
This will
denote, let's
denote,
say,
let's
mobility
say, mobility
times
times
the delta t,
the delta
or
t,
in
or
more
in
conventional
more
way this can be
conventional
written
way,
as
this can be
ki
written as Ki
delta t
delta
I.
T I.
So
So
now
now,
theoretically
theoretically
and
and
also
also from
experimentally, this
experimentally,
term
this
is
term
very much
is
larger
very
when
much
compared to
larger when
delta t.
compared to
So
delta
delta
t. So
t
delta
change
t change
doesn't very much
doesn't
affect
very much affect
the total,
the total
the
the
speed
the
or
speed
the velocity
or
of
the
a
velocity of
solid
a
liquid
solid
interface with
liquid
which
interface with
it
which
grows.
it grows.
So
So
this is the
this is
relation
the
for solid
relation
liquid
for solid
interface
liquid
of
interface
rough
of
surface.
rough
Now what
surface.
about
Now what
the smooth
about the
surface?
smooth surface?
Now at smooth
Now it's
surface,
smooth
and
surface,
because
and because
these
and
can be
these
easily
can
shown
be
by
easily shown
non-metals,
by non-metals,
right?
right?
These are even
These are
shown by
even
those
shown by those
elements which has high
elements which
entropy
has
of
high
melting,
entropy of melting,
right? To
right?
like
To
to
like
reduce
to reduce
the minimum
the
to have the
minimum to
minimum
have the
broken
minimum
bonds,
broken
they try
bonds.
to
They
have
try to
a
have
very flat
a very
surface
flat
when
surface
compared to
when
rough
compared
surface.
to rough surface.
Okay.
Okay.
Now,
Now,
if we want to
if we
grow
want to
anything
grow
onto this
anything onto
rough surface,
this
the
rough
flat
surface, the
surface,
flat
let's suppose
surface,
if
let's
something
suppose if
gets added
something
on,
gets added
let's
on,
say
let's say
a small thing
a
tries to
small thing
nucleate,
tries to nucleate,
and because
and
there
because
is a large
there is a
surface area
large surface area
that is being
that
formed,
is being formed,
it will again get
it will again get
melted.
melted.
So that's why
So that's why
for atomistically
for
smooth
atomistically
surfaces,
smooth
there
surfaces,
must be
there
formation
must
of
be formation of
ledges like this,
ledges like this,
right? So
right? So
that's way.
that's
So
way.
that way,
So that
the
way,
atoms
the
when they
atoms
try to
when they try
solidify
to
or
solidify
when we try
or
to
when we
stick to
try
the
to
surface,
stick to
they
the
can
surface, they can stick
to these
to
surfaces,
these
right?
surfaces,
There
right?
is a
There is a
surface area here
surface area
which
here
can
which
minimize
can
surface
minimize
area.
that surface area.
So
So
that's how
that's
it
how
is
it is
forming. So this
forming.
can
So
be
this can
readily
be
see when
readily
you
see
try to
when you try to
remelt the
melt and
gallium.
remelt the gallium.
You can see this
You
type
can
of
see this
surfaces.
type of surfaces.
Now,
Now,
to grow
to
any
grow
type of
any type of
grains on these
grains on these
flat surface,
flat
atomistically
surface,
flat
atomistically
surfaces,
flat surfaces,
you cannot have a
you
small
cannot have
nuclei,
a small nuclei,
right?
right?
You need to have
You
a
need to
larger
have a larger
nuclei of radius
nuclei
r,
of radius r,
such that,
such that,
let's say,
let's say,
we have discussed
we
this
have
part.
discussed
So
this part.
this is my
So this
delta
is
g.
my delta g.
Then
Then
this is
this
my
is
r
my
square.
r square.
This is my
This is my
r cube
r cube
term,
term,
right?
right?
So
So
it will more
it will more
look like this. So
like
this is
this.
my
So this is my
r star.
r star.
So for these
So
type
for
of
these type of
surfaces, for
surfaces,
nuclei
for
to
nuclei
form,
to form,
they need to
they
have
need
a
to have
larger
a
r star,
larger R star,
right? And the
right?
larger r
And the
star can
larger
be
R star
only
can be
formed,
only form
this larger
this
r
larger
star
R star
or the critical
or the
nuclei
critical
forming
nuclei forming
can be only
can be
possible
only possible
when
when
delta GeV
when
is
delta
very
G
less.
is very
So
less.
delta
So
GeV can be
delta
very
GV
less
can be very
only
less
when
only when
which
which
has a
has a
direct
direct relation
relation
to
to undercooling,
undercooling,
right? With the inverse
right? With the
relation to
inverse
undercooling.
relation to undercooling.
Write this
We
again.
write this again.
Yeah.
Yeah.
So
So
for larger
for larger
undercoolings,
undercoolings,
you will get a
you will
larger
get a
radius.
larger
So
radius.
that's
So
what
that's
happening here.
what happening here.
Here you have
Here
an
you have
exponential
an
term. So
exponential term. So
this the disk,
this, the disk,
right? So
right?
let's say this
So
is my
let's say this
disk.
is my disk.
So this
So this
planar interface
planar
will
interface
grow
will grow
with respect to
with respect to
the function of
the function of
delta t.
delta t.
That
That
means
means
it
it
mostly
mostly
depends
depends
upon
upon
rather
rather
than
than
the
the
mobility,
mobility, it will
it
mostly
mostly
depends
depends
upon
upon
the
the
undercooling.
undercooling. The higher is the
The higher is the
undercooling,
undercooling,
the faster
the
will
faster
be the
will be the
this
this
disk on
disk
atomic
on
flat
atomic
interface
flat
will form.
interface will form.
Right
Right
now,
now,
here you can see
here
the
you can
different
see
types
the
of
different types
growths.
of growths.
So the first
So the
one
first
has
one has
direct relation,
direct relation,
the continuous
the
growth, which
continuous growth, which
mostly doesn't depend upon the
highly doesn't depend
undercooling.
upon the undercooling.
So that is
So
here.
that is here.
Now the
Now,
next one is the
the next
spiral
one is
growth.
the
The
spiral
spiral
growth. The
growth is
spiral growth
observed
is
in
observed
screw
in the
dislocations,
screw
right? So
dislocations, right? So
screw
screw
dislocations I cannot
dislocations I
draw,
cannot
so they
draw
are
it, so they
actually
actually
right.
right. So
So let's say this
so
is
let's
my
say
screw
this is my
dislocation
screw
that has been
dislocation that
formed
has
here
been formed here
on this solid.
on this
Now
solid.
the atoms
Now
will
the
try to
atoms
sit
will
here,
try to sit here,
right? And
right?
this will
And
the
this
process
will
will
the
go on.
process will
It
go
will
on.
take
It
a
will take
spiral
a
path,
spiral path,
right? So
right?
that is
So
about
that is
the
about
spiral
the
growth,
spiral growth,
and we have the
and
surface
we have the
nucleation
surface
here.
nucleation here.
So here you can
So
see
here you can see
the relations.
the relations
At higher
at higher
undercoolings,
undercoolings, everything
gets converged.
gets
Okay,
converged. Okay, now
that is about
that is
the
about
growths.
the
Now,
growths. Now,
again,
again,
how do we
how do we
represent
represent
the
the
growth
the growth
kinetics in terms of
kinetics in
heat flow?
terms of heat
Right,
flow?
how the heat
Right, how
is
the heat
being
is being
here
here
we
we
didn't mention
we
anything
didn't
about
mention
the heat
anything
flow,
about the heat flow,
right? So
right?
whatever the
So whatever the
things we have been
things we
discussing
have
here,
been
we
discussing
only
here, we
represented
only
the temperature.
represented the
We have
temperature.
represented the
We have
term
represented the
temperature,
term
how
temperature,
the
how the
temperature
temperature
affects
affects
our undercooling
how
affects our
undercooling affects
growth.
our growth.
But
But
what about the heat
what
flow?
about the heat flow?
So we have to
So we
mention
have to
that
mention
term too,
that term too,
right?
right?
Now,
Now,
how we are going to
how we are
represent
going
it?
to represent it?
That is the question.
That is the question.
We have
We
a
have
solid liquid
a solid
interface.
liquid interface.
Okay, so
Okay,
just
so
like I have mentioned
just like I
before,
have mentioned before, let me let's say this is my
solid.
solid.
Let me
Let me
draw the atoms.
draw the atoms.
So these
So
are my
these are
solid
my
atoms.
solid atoms.
Okay,
Okay,
yeah,
yeah,
they're perfectly
they're
arranged.
perfectly arranged.
Let's say, for
Let's
example,
say,
they
for
are
example,
arranged
they are
perfectly.
arranged perfectly.
Okay.
Okay,
Now what about
now what about
the liquid
the
atoms?
liquid atoms?
The liquid
The
atoms are
liquid
not
atoms are
perfectly
not
arranged. They are
perfectly
more
arranged. They
random.
are more random.
Right.
Right now,
Let's say
let's say
this is my
this
solid.
is my
This is
solid.
my liquid.
This is my liquid.
Right now, what I'm
Right
trying
now,
to do
what
is
I'm trying to do
I'm
is
trying to
again, I'm
draw the
trying to
heat.
draw the heat.
Let's say the liquid
Let's
is
say
at
the
high
liquid is at
temperature.
high
Okay.
temperature.
So
Okay,
let's
so
say
let's talk about the
pure
water,
water.
pure
There is no
water. There is
mineral or
no
nothing
mineral or
added,
nothing
pure
added, or
deionized
pure
water.
deionized water. Okay,
Now
now
this is, let's
this
say,
is,
the
let's say,
interface
the
is at
interface is at
100 degrees
100
centigrade,
degrees centigrade,
and there is still
and
heating
there is
here.
still
I'm
heating
heating
here.
from
I'm
this side.
heating from this side.
Okay. So
Okay, so
let's say I have
let's
here
say I have here
120 degrees
120
centigrade.
degrees
Now what
centigrade.
I'm trying to do
Now
is
what I'm
I'm
trying to
trying
do
to
is
cool
I'm
it from
trying to
here.
cool
So
it
I'm
from
trying to
here. So
draw
I'm
the
trying
heat
to draw the
from
heat from
right to left.
right to left.
Okay. So let's say
Okay,
this
so
is
let's
here.
say
The
this is
temperature
here.
is
The
60
temperature
degrees
is 60
centigrade.
degrees centigrade.
So the heat
So
is
the heat
flowing
is
from
flowing from
right to left.
right to left,
Right.
right?
So that is how
So
my
that is
heat is
how my
flowing
heat is flowing
from right to left.
from right to left.
Now,
Now,
what is my thermal
what is my
gradient?
thermal gradient?
See, if this is
See,
my
if this is my
interface,
interface,
I'm not going to
I'm
draw
not
these
going to
atoms
draw
again.
those atoms
So
again. So
here it is 100
here it
degrees
is 100
centigrade,
degrees
here it is
centigrade,
60
here it
degrees
is 60
centigrade.
degrees
So
centigrade.
I
So
have a
I
thermal
have a
gradient
thermal gradient
like this.
like this.
Let's say it is
Let's say it
a
is
linear
a
thermal
linear
gradient. Okay,
thermal gradient.
let's
Okay,
not make
let's not make
complex
complex
derivation complex.
derivation
Let's just
complex.
assume it
Let's
is a
just assume
linear
it is a
thermal
linear
gradient.
thermal gradient. Okay.
Now,
Now,
what about the
what
liquid?
about the
Liquid
liquid?
is
Liquid is
at
a
deep it is
at
120
deep it
degrees
is
centigrade.
120 degrees
So
centigrade. So
I have
I have
another thermal
another
gradient.
thermal gradient.
Let's say this is
Let's say
distance
this is distance
1. This
1.
is distance,
This is
unit
distance,
distance.
unit distance.
Right.
Right.
And what do we mean
And
by
what do we
thermal
mean by
gradient?
thermal
Which is
gradient? Which
dt
is
by dx.
dt by
And for
dx.
larger
And for
distance,
larger
if it is
distance,
a
if it is
linear
a
path,
linear
it
path,
is
then
delta t
it
by
is delta t
delta
by
x.
delta x.
Right.
Right.
What does that mean?
What does that mean?
T1 minus
T1
T2
minus or
minus
T2
T1 by
minus
x2
T1 by
minus
x2
x1.
minus x1.
So for 100
So
to
for
60,
100 to
what is
60,
my
what
T2?
is my T2?
T2 is
T2 is
60 minus
60
100
minus 100
upon 1,
upon
which
1,
is 40,
which is 40,
which is minus 40.
which is minus
So
40.
negative
So negative
thermal gradient.
thermal gradient.
Here I have
Here I have
negative
negative
thermal gradient.
thermal gradient.
T is represented
T is
as
represented as
delta T by
delta T
delta
by
x
delta
or
x or
dou T by
dou
dou
T
x.
by dou x.
Okay.
Okay.
So here I have
So here I have
negative thermal
negative
gradient.
thermal gradient.
What about here?
What about here?
dt upon
dt
dx,
upon dx.
delta t
Okay.
upon
Delta
delta
t
x.
upon
If we
delta
are
x. If
assuming
you
the
are
linear
assuming the
equation.
linear equation.
So
Okay.
t2
So
minus
T2
t1 by
minus T1
x2
by
minus
x2
x1.
minus x1.
What is my t2?
What is my
T2 is
T2?
120
T2 is 120
minus 100
minus 100
upon 1,
upon
which
1,
is 20.
which is 20.
Here I have
Here I have
positive thermal
positive
gradient.
thermal gradient.
This is 1,
This is
this
1,
is 2.
this is 2.
Positive thermal
Positive
gradient.
thermal gradient.
Now,
Now,
what happens here?
what happens here?
So, if
So, if,
and
and
drawing it
I'm
again,
drawing it again,
and because I have
and because I
negative
have
thermal
negative
gradient
thermal
here
gradient
and have
here and
positive
have
thermal
positive
gradient
thermal
here,
gradient here,
let's say if I try
let's
to
say if I
draw
try
heat,
to draw
then what
heat,
happens
then what
here?
happens
A
here?
small
A
amount of
small
liquid
amount of
will
liquid
transform
will
into
transform into
solid.
solid.
Right?
Right.
A small amount of
A
liquid
small amount
transform
of
into
liquid
solid.
transform into
So
solid.
during
So
transformation,
during
there is a
transformation,
rejection
there
of
is a
heat.
rejection of heat.
Right? So that is
Right.
the
So that
enthalpy
is
of
the
fission.
enthalpy of fission.
Now, how do I
Now,
relate
how
to
do
that?
I relate to that?
The amount of
The
energy
amount of energy that has been created
during
during
solidification will be
solidification
given by
will be given by
velocity
velocity
front
front
times
times
LB,
LB,
the enthalpy of
the
fission.
enthalpy of fusion.
Right?
Right.
Now,
Now,
what about the
what
thermal
about the
gradient? So
thermal
the heat
gradient? So the
generated
heat
here
generated
plus
here
the heat
plus the heat
coming
coming
from
from
here will
here
be
will be
equals to
equals
heat
to
which
heat
is taken out
which
from
is
here.
taken out from here.
Right? So
Right. So
Q1 will be equals
Q1
to
will be equals
Q dash
to
that is
Q dash that
generated
is generated
plus Q2
plus
that is
Q2
being
that
drawn
is being
from
drawn from
liquid side.
liquid side.
Right? So what is
Right. So
Q1?
what is
Q1
Q1?
is
Q1 is
K
K
thermal conductivity of
thermal
solid
conductivity of solid
times
times
the thermal
the
gradient
thermal
of
gradient of
solid
solid
will be equals
will
to
be equals to
Q,
Q,
which is
which
velocity
is velocity
times
times
the enthalpy of
the enthalpy of
melting, right?
melting,
That
right?
will be equals
That
to
will be equals
LS.
to
Let's write
Ls. Let's write
LS
Ls
times
times
thermal conductivity of
thermal
liquid
conductivity of
times
liquid
the thermal
times the thermal
conductivity of
conductivity
in liquid.
in liquid.
So
So
let's say
let's say
let's say
let's say
if a small
if a
protrusion
small
happens
protrusion
here,
happens here, let's say
at one
at
position
one position
more, let's say.
more, let's
So
say,
when I'm trying
so
to
when I'm
draw
trying to
heat
draw
from one
heat
side,
from one side,
so this is
so
the
this
ideal
is
case.
the ideal case.
This is the amount of
This is the
liquid
amount
that
of
has been
liquid that
transformed
has
to
been
solid.
transformed to
So
solid.
for example,
So, for example,
at
at some
some
position,
position,
let's
let's say
say
the
the
more
more
number
number
of
of
atoms
atoms
have
have
tried to solidify
tried
here.
to solidify here. So when compared to this surface has came deeper into the liquid. Right.
Now,
Now
let's take
let's take
a phase diagram.
a phase diagram.
Okay.
Okay.
So I'm talking
So
about
I'm talking
this
about
phase diagram.
this phase diagram.
Let's say this is my
Let's say
liquid,
this is my
solid,
liquid, solid,
liquid
liquid plus
plus solid.
solid.
Now,
Now if
decrease the
I decrease
temperature,
the
then
temperature,
only my
then only my
solid is going to
solid is
solidify.
going to solidify.
Right. If I
Right.
try to
If I
increase
try
my
to increase
temperature,
my
the
temperature,
solid will
the
again get
solid will again get
the liquid fraction
the
will
liquid
get
fraction
increased.
will get increased.
Right. Then that
Right.
means
Then that
solid
means the
cannot
solid
sustain
cannot sustain
in liquid.
in liquid.
Suppose
Suppose the solid can sustain up to 102 degrees centigrade.
So this
So
protrusion
this
has
protrusion
went deep
has
into the
went
liquid
deep into the
and
liquid and
touched the
had
thermal
touched
line
the
of
thermal line of
103 degrees
103
centigrade.
degrees centigrade.
So what happens?
So what
So
happens?
that solid
So that
cannot
solid
remain
cannot
there.
remain
It's
there.
not stable
It's
there.
not stable
So it
there.
will again
So
get
it will again get
melted,
melted,
melted and get
melted
into the
and
liquid.
get into the liquid.
So
So
in pure
in
metals,
pure metals,
that means
that
here we
means
have taken
here
pure
we have
water.
taken
Now
pure
let's
water.
change the
Now
topic to
let's change
pure
the
metals.
topic to pure
In pure
metals.
metals,
In pure metals,
if we have
if we have
in pure metals,
in pure
if
metals,
we have
if we have
a
a
positive
positive
thermal gradient
thermal gradient
in liquid,
in liquid,
then
then
what happens?
what happens?
Then
Then
the possible
the possible
shape,
shape,
possible
possible
shape
shape
of solid
of
liquid
solid liquid
interface is
interface is
planar.
planar.
Right? If a
Right? If
protrusion
a
forms,
protrusion
then again it
forms,
will
then
get
again it
dissolved
will get
because of
dissolved
the high
because of the
temperature.
high temperature.
So that is about
So that is about
the
the
growth of planar
growth of
interface.
planar interface.
Right. Now
Right? Now
that will be given
that
by
will be given by
V
V
equals
will
to
be equals to
KL
KL
KS
KS
minus T
minus T
thermal gradient S
thermal gradient
minus
S minus
KL
KL
TL
TL
upon
upon
the enthalpy
the enthalpy
term.
term.
Right. So
Right? So
this is my third
this
part.
is my third part.
Now
Now,
what happens
what
if
happens
my
if
thermal
my
gradient
thermal gradient
my thermal gradient
my
is
thermal
0
gradient is
in
0
solid
in solid
and
and
there is a negative
there is a
thermal
negative
gradient in
thermal
liquid.
gradient in liquid?
So this is what
So
happens
this is
in
what
most of the
happens in
cases
most of the cases
because we do not
because we do not
pour
pour
them.
them.
We
We
try
try
to
to
cool
cool
the
the
melt.
melt.
Right? We do not
Right? We do not
superheat the melt.
superheat the melt.
Right? So
Right? So
if we have
if
negative
we have negative
thermal gradient,
thermal gradient,
now what happens?
now what happens?
So
So
if
if
after time
after
t2
time
some part
t2 some
is
part
getting
is
transformed
getting transformed
at solid liquid
at solid
interface.
liquid
So
interface. So
for example,
for
if
example,
so
if
if
so if
for once
for once
more number of
more
atoms
number of
try
atoms
to
try to
accommodate here,
accommodate here,
get transformed
get
into solid.
transformed into solid.
Now this
Now this
protrusion
protrusion
has
has
gone deep into the
gone deep
liquid,
into the liquid,
right?
right?
Now as
Now
here
as
let's say I have
here
100
let's say I have
degree, here
100
I have
degree,
90
here I
degrees,
have 90
here I have
degrees, and
90
here I
degrees,
have
and here
90,
I have
and
80.
here I have 80.
Deep into the liquid.
Deep into the liquid.
Now
Now
the case is
the
opposite
case
here.
is opposite here.
Before we have a
Before
positive
we have
thermal
a positive
gradient, we
thermal
have high
gradient, we
temperature,
have
so
high
it will
temperature,
get
so
again
it will get again
remelted. But here
remelted.
it's
But
not the
here
case.
it's not the case.
What happens?
What happens?
What is happening
What
here?
is happening here
It
is
is again
it
getting
is again
it's
it's
getting
getting
solidified. So
solidified.
it is more
So it is
preferable
more
to get
preferable to
solidified.
get
So
solidified.
more
So
this
more this will
will try to
again
grow
will try to grow
with time.
with time.
Right?
Right?
Again,
Again,
and this surface
and
also
this
they will
surface
try
also
to
they
grow.
will try to grow.
So
So
even at this
even
surface
at this surface
they also try
they
to
also try to grow.
grow. Right?
Right?
So these are
So
called as
these are called as
dendrites, and
dendrites,
because they
and
are
because they are
happening in
happening
pure metals, they
in
are
pure
happening
metals, they are
because of
happening because
temperature.
of
They are called
temperature.
as
They are
thermal
called as thermal
dendrites.
dendrites.
So
So
they are
they
called
are called
thermal
thermal
dendrites.
dendrites.
There is only thermal
There is only
undercooling,
thermal undercooling,
right? So
right?
because of the
So
temperature
because of the
cooling,
temperature cooling,
they are formed.
they are formed. That's why they are called as thermal dendrites.
Now,
Now,
how do we
now
derive
how do
the
we
spark,
derive the
right?
spark,
So let's
right?
say
So
this
let's
is my
say this
solid
is my
now,
solid,
and I'm talking
and
about
I'm talking about
radius r.
radius r.
Then,
Then,
if I'm only
if I'm
consider
only consider
about
about
this part,
this part,
so that can
so
be
that can be more or less
approximated to
approximated to
half
half
the times of
the
surface
times
area
of
of
surface area
sphere
of sphere
times
times
q naught.
q naught.
Heat
Heat
taken out
taken out
times
times
the velocity
the velocity
times pi
times
r
the
square
pi r square
times delta
times
h
delta
upon
h upon
vs, volume of the
Vs,
solid.
volume of the solid.
Right. So
Right. So
velocity front
velocity front
will be
will be
given by
given by
q dash
q dash
vs
Vs
upon
upon
r
r
delta h.
delta
Now
hl.
we know
Now
the
we
q
know
dash,
the q
the amount
dash,
of heat
the amount of heat uh,
that has
that
been
that has
taken out,
been taken out
equals
will
to
be equals to
kl
kl
tl minus
tl
ks
minus ks
ts
ts
upon
upon
r.
r.
So if I
So if
substitute
I
that
substitute
here,
that here,
will be equals to
will be equals
kl
to
tl
kl
minus
tl
ks
minus
ts
ks ts
times volume of the
times volume of the
solid
solid
divided by
divided
r
by
into
r
delta
into
h.
delta hl.
So this is my
So this is my
velocity front,
velocity front.
right? And
Right. And
if I assume
if I assume
the thermal
the thermal
conductivity
conductivity
is zero,
is zero,
or if I
or
take
if I
the
take
t, the
the
thermal
t, the
gradient
thermal
is zero.
gradient is zero.
Okay, so
Okay.
there is no
So
thermal
there is no
gradient.
thermal gradient.
Instead of assuming
Instead of
thermal
assuming
conductivity
thermal
is zero,
conductivity as zero,
we
we can
can
assume
assume
thermal
gradient is zero.
gradient is zero.
Right? Then what
Right.
happens?
Then what happens?
This will turn out to be
This will
zero,
turn out to be zero.
and v naught,
Then V naught,
the velocity will
the
be given
velocity
by
will be given by
the velocity will
the
be given
velocity will be given by
by kl dash
KL dash
times
times
TL dash
TL dash
upon Vs
upon
divided by
Vs divided by
R
R
delta HL
delta HL
is my velocity.
is my velocity.
One more
Okay,
slide.
one more slide.
So
So
that TL,
that TL,
the thermal
the
gradient
thermal
will be given
gradient
as
will be given as
T
T
melting
melting
minus T.
minus T.
The thermal
The
gradient will be
thermal
given as
gradient will be
T.
given
Sorry,
as T. Sorry,
let's
let's
write it
write
again.
it again.
This
This
thermal
thermal
gradient,
gradient, which
which is
is
in liquid, will be
in
given by
liquid, will
T
be given
at
by T
interface
at
minus T
interface minus
deep
T
into the liquid.
deep into the liquid.
Right
Right.
now,
Now,
what is my
what
velocity
is my
front
velocity
equation?
front
Which is
equation? Which
minus
is minus
KL
KL
Ti minus
Ti
T
minus
deep
T
into the
deep
liquid
into the liquid
times
times
enthalpy of fusion
enthalpy of fusion
times the R.
times the R.
Now,
Now,
and because
and
I
because
have a
I
surface
have a
like this,
surface like
because I
this,
have a
because I
curvature,
have a curvature,
and there is also a
and there is
curvature
also a
undercooling,
curvature undercooling.
right? And
Right.
what is my
And what is
curvature
my
undercooling?
curvature undercooling?
We need to do
We need to
undercooling,
do
right? Because
undercooling,
there is
right?
a
Because there is
formation
a
of a
formation
curvature.
of a
So
curvature.
to
So
form
to
a
form
new
a
surface
new
area, because
surface
of this
area,
curvature,
because
we
of
are
this
forming a
curvature, we
new
are
surface
forming a
area,
new surface
and there
area,
is also this
and there is
excess
also
pressure.
this excess
So
pressure.
we need
So
to
we need
give some
to
amount of
give some amount
undercooling
of
to form
undercooling
this
to form
curvature,
this
right?
curvature,
So
right?
that
So
undercooling
that
will be given
undercooling
by
will be given by
T
T
melting minus
melting
Ti.
minus Ti.
That will be
That
equals
will
to
be equals to
2 gamma
2 gamma
Tm by
Tm by
enthalpy times R.
enthalpy times R.
How do I
Now,
arrive
how
to
do
this?
I arrive to
We
this?
know
We know R
R
will be
star will
R
be
star
equals
will
to
be equals to
2
2
gamma
gamma
divided by
divided by
delta G
delta
SL.
G
Now
SL.
we know
Now
delta
we
G
know delta
SL
G
will
SL
be equals to
will be equals to
L delta
L
T
delta T
upon Tm.
upon Tm.
So if I
So
substitute
if I
this here,
substitute this here,
this will turn out to
this
be
will turn out to
this.
be this.
This is the
This is
undercooling
the
from
undercooling
Tm
from
minus
Tm minus
Ti.
Ti.
Right. So
Right. So
let me write it.
let me write it.
Tm minus
Tm
Ti will
minus
be
Ti
equals
will be
to
equals
2
to
gamma
2 gamma
Tm
Tm
upon
upon
Ls
Ls
R.
times R.
Right. Now
Right. Now,
for,
for
let's say for
let's say
R
for
equals to R
R
star,
equals to R star,
let's say for a critical
let's say for a
radius,
critical radius,
right? For critical
right? For
radius, we
critical
need to
radius, we
achieve
need to achieve
the total.
the total.
So for a critical
So for a
radius,
critical
we need
radius,
to
we need to
achieve delta
achieve
T
delta T
L dot T naught,
L dot
which
T
is
naught, which is
Tm minus
Tm
T
minus T
infinite.
infinite.
Now,
Now,
how do I
how do I
get to this delta
get
T
to
naught?
this delta T naught?
Right? How do I
Right?
relate
How do I relate
this delta
this delta
T dash L,
T dash
which is
L,
delta
which
T
is delta T
undercooling due to the
undercooling due to
curvature?
the curvature?
Right? How can I
Right?
relate
How can I relate to
Tm minus T
Tm
infinite
minus
to
T
this guy?
infinite to this guy?
So that is our
So
question.
that is our question.
Now, the
Now,
minimum
the
possible
minimum
radius of
possible
curvature
radius of
for the tip
curvature for the
is
tip
when
is
Tr
when
equals to
Tr
the
equals
total
to the
undercooling
total
T naught,
undercooling T naught,
which is T naught
which is
T
T naught
melting
T
point
melting
minus
point
T
minus
infinite.
T
Now,
infinite. Now,
so therefore,
so
in general,
therefore, in general,
delta Tr
delta
can be
Tr
written
can
as
be written as
delta T naught
delta T naught
times R
times
star
R
upon
star
R.
upon R.
Right. So
Right. So
delta Tr,
delta Tr,
just I have defined
just I
before,
have
delta
defined before,
Tr
delta Tr
upon
upon
what?
what?
R star.
R
This is
star.
for critical
This is for
radius.
critical radius.
Now, what about
Now, what
for
about for
radius of R?
radius
That
of
will
R?
be
That
delta
will
T
be
naught,
delta T naught,
which is
which is
T melting
T
point minus
melting point
T
minus
infinite.
T infinite.
Right. So
Right.
delta T
So
naught
delta
will
T
be
naught
equals
will be
delta Tr
equals
will be
delta
equals
Tr
to
will be equals to
delta T naught
delta T
into
naught into
R
R
star
star
upon R.
upon R.
So now
So now
substituting
substituting
into this
into this
equation,
equation,
which is
which is
T
T
minus T
m
infinite,
minus T
which can be
infinite,
written
which
as
can be written
Tm
as
minus T
Tm
infinite
minus
can be
T
written
infinite
as
can be written as
Ti minus
Ti
T
minus
infinite
T infinite
minus
minus
T infinite
T infinite
or
or
T
T
m
m
minus Ti.
minus Ti.
Right.
Right.
So this is
So this
delta
is
T naught
delta T naught
minus
minus
delta
delta
Tr.
Tr.
Now we know
Now we know
delta T naught
delta T naught
is this part.
is this part.
So this
So
delta T
this
naught
delta T
will be
naught
equals
will
to,
be equals to,
let's write it here.
let's write it here. You
Delta
know,
T naught
delta T
minus
naught
delta Tr
minus
will
delta
be
Tr will be
this one.
this one.
So
So
delta T naught
delta T naught
times R
times
star
R
upon
star
R.
upon R.
Now,
Now,
upon taking this
upon
term
taking
out,
this term out,
so V
so
will be
V will be
KL
KL
upon L
upon
naught
L naught
LS
LS
into 1 by
into 1
R
by R
times
times
1 minus
1
R
minus
star
R
upon
star
R.
upon R.
So this is the
So
relation
this is the relation
upon
upon
doing many
doing many
simplifications.
simplifications.
Now,
Now,
this is all
this
about
is all
the
about
pure metals.
the pure metals.
Now, what about
Now,
if
what
I
about
have an
if
alloy?
I have an alloy?
Right. So
Right.
let's say
So let's say
if I have an
if I
alloy
have
of
an alloy of
AB, so
AB,
B in
so
A.
B in A.
Okay.
Okay.
So my main
So my
constant
main
is B
constant is
and my
B,
minor
and
addition
the
is
minor addition is
So
So
main
main
constituent
constituent
is
is A
A and minor
and
addition
minor
is
addition
B.
is B.
Right. So
Right.
this is
So
about
this is about
A and B.
A and B.
Thing.
Thing.
Okay.
Okay.
Now
Now
let's take
let's
one
take
simple phase
one
diagram.
simple phase diagram. Okay.
Let's take
Let's take
an isomorphous
an
phase diagram
isomorphous phase diagram
for simplicity.
for simplicity. So
Have A
have
as a
A
higher
as a
melting
higher
point when
melting
compared
point
to
when
B.
compared to B.
This is pure
This
A.
is
This
pure
is
A.
pure
This
B.
is pure B.
Yeah.
Yeah.
So let's say I'm
So
at
let's say I'm
composition
at composition
X naught.
X naught.
At T1
At
I have
T1,
total
I
liquid,
have total liquid,
but at
but at
T2
T2,
I still have
I
total
still
liquid.
have total liquid.
So
So
what is my
what is
composition
my
of liquid?
composition of liquid?
Will be
Will be
X naught.
X naught.
Right.
Right.
Now
Now,
if I try to
if I
cool
try to
below
cool
T2,
below T2,
let's say
let's
I'm at
say I am at
T3.
T3.
At T3
At
my
T3,
composition
my
of
composition of
solid
solid
is
is
XS and my
XS,
composition
and my
of liquid
composition of liquid
is
is
XL.
XL.
And we defined
And
a
we
partition
define a
coefficient
partition
which
coefficient,
is K
which is K,
will equals
will
to
be equals to
XS upon
XS upon
XL.
XL.
And this is only
And
taken
this is only
for
taken for
straight lines,
straight
right?
lines,
The phase
right? The
diagrams
phase
which
diagrams
have straight
which have
lines.
a straight
So
lines.
let's say this
So
is my
let's say
straight
this
line,
is my
but
straight line.
here you cannot
But here you
use
cannot
this
use
K. This
this
K
K.
will
This
keep
K
on
will
changing
keep on changing
depending upon X's
depending
and
upon
XL.
XS and
For
XL.
straight line the
For
K
straight line,
remains
the
same.
K
The
remains
K,
same.
K
The
remains
K
constant.
remains constant, right?
So
So
yeah. So let's
yeah.
say
So let's
at
say at
at this
yeah,
point
at this point,
XL is
XL
X naught.
is X naught.
Then what
Now
about
then what about
XS? XS
XS?
will be
XS will be
the weight fraction of
the weight
solid
fraction
will
of
be K
solid will
times
be K
X
times
naught.
X naught.
Right. So
Right.
what's
So
happening is
what
when
happening
we're
here
trying
is
to
when we're
cool
trying to cool
the
the
solid fraction
solid
or
fraction
the
or
mole fraction of
the mole
solid
fraction of
or
solid or the
fraction in
solid
solid
fraction in solid
will go on
will go on
increasing from
increasing
point
from point
1 to
1
2
to
to
2
3
to 3
to finally
to
reaching
finally
4
reaching
of
4
x naught.
of X
But
naught.
what about the
But what
liquid?
about the liquid?
When I try to
When I
cool the
try to
liquid,
cool the liquid,
it
it
go on
go
it keep
on
on
it
getting
keep on getting
richer in
richer
B.
in B.
Finally, the
Finally,
whole liquid
the whole
vanishes.
liquid
Right.
vanishes.
So the whole
Right. So the liquid
one, two dash,
1, 2 dash,
three dash,
3 dash,
four dash,
4
five
dash,
dash.
5 dash.
So when I try to
So when I
cool
try to
the
cool
liquid,
the liquid,
the solid
the
gets
solid
richer and
gets
richer
richer
in
and
B,
richer in B,
and also the
and
liquid
also the
gets
liquid
richer
gets
in B.
richer in B.
Right. So
Right. So
let's say if
let's
I
say
try,
if I
see you
try,
can see
see
here.
you can see here.
Now
Now
this is my
this
solidus
is my
line.
solidus
This is
line.
my
This is
liquidus
my
line.
liquidus line.
Now
Now
let's say this is
let's
my
say this
melt.
is my melt.
Let me erase
Let
this
me
part.
erase this part.
Yeah.
Yeah.
Let's say this is my
Let's say
melt,
this is the melt,
and I'm trying
and
to
I'm
cool it
trying to cool
from the outside.
from
So
the
I'm
outside. So I'm
taking the heat
taking the heat
laterally.
laterally.
Right.
Right.
Now this part will
Now this
transform
part will
at
transform
first.
at first.
So this all will
So this
transform.
all will transform.
Let's say
Let's say
this is the part
this is the part
that has been
that has
solidified.
been solidified.
Let's say it is at
Let's say it
temperature
is at
T1
temperature T1
less than T.
less than
So
T.
So its
its
mole
mole
fraction
fraction
will
will
be
be
xs1.
xs1.
Now
Now,
after time
after
t2,
time t2,
and because the
and
liquid
because
has
the liquid
higher,
has higher,
and here the liquid
and
has
here the liquid has
higher mole fraction,
higher mole fraction,
right? So
right? So
now
now
xs1,
xs1,
and
and
let me write
let me
the same
write
part,
the same part,
xl1.
xl1.
Again,
Again,
after time
after
t2,
time t2,
another solid will
another
form.
solid will form.
Here
Here
it will have
it will have
xs2
xs2
and
and
xl2.
xl2.
Again, if I
Again,
try to
if I
decrease the
try to
temperature
decrease the
more,
temperature more,
if I try to
if I
maintain the
try to
temperature
maintain the
below
temperature
T1,
and below
let's say
T1, let's say
I am trying to decrease
I'm
the
trying to
temperature
decrease the
more, then
temperature
what
more,
happens?
then what happens?
Again,
Again,
another solid
and another
forms,
solid forms,
right? Which
right?
will have
Which will have
XS3,
XS3,
XL3.
XL3.
So different
The
composition
different
of solids
composition of
in
solids in
melts.
melts.
So what happened
So what
is
happened? What's happening here is
the mole fraction
the
of
mole
solid,
fraction of solid,
or the weight
or
fraction,
the weight
or the amount
fraction,
of
or the
solid
amount of solid
is getting
is
richer and
getting
richer
richer
in B.
and richer in B.
Right? That is what
Right?
we see.
That is what we
And
see.
because of
And
this
because of this
compositional difference
compositional difference
from periphery to
from
center,
periphery to center,
we call it
we
as a
call it as a
coring.
coring.
And it all
And it
happens
all happens
because of the
because of
diffusion,
the
lack
diffusion,
of
lack of
diffusion
diffusion
of
of
atoms
atoms
in solid.
in solid.
Right? Because
Right?
of
Because of
the less amount
the
of
less
diffusion
amount
when
of
compared
diffusion when
to
compared to
liquid.
liquid.
So
So
you have this
you have
compositional
this
variation.
compositional variation.
Right? So
Right? So
yeah,
yeah,
that is about
that is about
this part.
this
And
part. And
in next lecture we
in
will,
next lecture we will, in next session we will
derive
try to
the
derive
liquid
the
front
liquid
velocity,
front velocity,
this liquid front
this liquid
velocity
front velocity
in solute
in
intercooling.
solute intercooling.
Okay?
Okay.
Yeah,
Yeah,
that's all for
that's
today's
all for
session.
today's session.
Thank you.
Thank you.